Okay, getting another stream going. Hello, everyone. So, the first thing on the agenda here is actually to just restart this experiment that I was doing last time with this board. So, I put together a standalone, well, kind of standalone version of the earlier experiment for determining interesting SD card file names. And that is now running pretty much self-contained on this FPGA board. It still needs a connection to some host with a serial port in order to log the output, though. I could have made it log locally, but it seemed overall simpler and more reliable to have it log externally. And of course, that was what failed. And it wasn't a big failure, so I left this running for a while, and it's a program that's basically trying to brute force the first 4 characters of a file name so that it can look for a small side channel artifact, in this case a timing difference in the SD card read requests, in order to figure out which file names might be interesting to the firmware by looking for some additional progress it's making in what seems to be some kind of aligned mem compare that it's doing on all the file name entries. So that was humming along pretty nicely, but I think I haven't totally determined the root cause. It might have been cat related, it might have been just bad power management settings on my laptop, but the laptop ended up losing some of the serial output. And I don't think anything interesting happened during that, but it seems safest to just start the experiment over with known parameters and make sure that I record it all. So I'm also taking this as an opportunity to move it from the laptop that the cat really seems to like laying on over to this spot on top of the VCR or next to the oscope. This is my cat. His name's Tuco. He likes fetching nylon bolts. He's been picky about food lately. He seems to really only want this one particular kind of wet cat food now, and I think I just gave him my last can of that today, so he might have to subsist on different kinds of cat food until I can get some more of that, in the next day or two. So, on the agenda for this stream, first thing, I just want to get this experiment restarted. The slow part there was actually just copying the virtual machine that I needed. Oh, geez, Tuco, don't trigger the copyright bot. Shit. No, sorry. Oh man, that would be the worst way to get a takedown notice. Accidentally had a song played by my cat. Was incinerated by fiery lawyer Doom from YouTube. Yeah. Thanks, Tuco, for keeping things exciting. Man, what computer was that even playing from? I guess this was... Yeah, anyway. The surprising facts of the audio routing setup here. So, anyway, first order of business is just to get this experiment restarted. In fact, using the very keyboard that Tuco was just about to get me my takedown notice through. So let's get that back on the screen here. Good afternoon, everyone. It feels like morning here. I don't know, I've been on like a late schedule. I've been working late and then kind of getting started slowly in the morning and then working late again. I don't know, if it works, I don't complain too much. That is just a silly password for the stream. I think I just used... No? Tuco, did you, mess up, the modifier key state on this machine? Oh, I think I used the other temporary password. Yeah, this is the even worse one that I use for VMs. Well, the longer one isn't like a bad password, it's just not one that I really care if people know on the outside because it's not useful outside my network. This is the even weaker password that I use for virtual machines that are already protected elsewhere. Phil suggests to start screaming loudly if the song starts playing to drown it out. Yeah, that sounds about right. Like, I was finding myself looking around for, like, oh no, what cable do I unplug? But then it's like, oh no, I don't even know what computer that's playing on. Because I think what he did was he pushed the play button on the computer I'm interacting with here right now, but I suspect it wasn't actually playing locally. I think that was like the Spotify remote, which was actually playing it off of... If it was playing off of the same computer that was actually doing the audio recording right now, then it wouldn't end up directly on the stream. It would just end up on the stream through the microphone and speakers. But anyway. Yeah, in that case, screaming over it probably would have been pretty effective because there wouldn't be a local copy of the audio getting mixed in. Hey Tuco, it's okay. I'm not going to blame you when the lawyers knock on my door. I'll blame, how I didn't properly secure my music collection from unauthorized playback with a little flip cover on the play button, That'll be the new requirement on keyboards. Okay, so this is a little bit convoluted, but I ended up having to bring over my entire virtual machine just to run this experiment, because even though I mostly just need a logging serial terminal, I need to send it the actual program. And so I could have solved this by copying the binary over from the virtual machine, but I already had the virtual machine powered off so that I could rsync it over to this machine. So I ended up just having to wait on the whole VM to copy because I needed either the binaries or I needed a binary version of the system on chip that I could then compile the application against because it has like dependencies anyway. Made this slightly unnecessarily complicated, but that all had me wishing that, oh, maybe I should have just given it like an SD card host port so that I could put another SD card into the SD card emulator that it could then log to, and that would be really convenient. So I might save that for another revision because I've got plenty of free I/O on the board. I don't know how much more I can squeeze into the FPGA in terms of a hardware SPI host or a hardware SD controller. But if I need to, like I've already got the hardware to map out all of my unused pins to GPIOs, so I could always bitbang an SD card interface, which might be fast enough for logging, and that wouldn't take up any additional space in the FPGA. So anyway, I just copied over this VM, so it should be pretty much in the same state. It should already have my compiled files in it. So I just need to get it started. This right here is just for a little bit of context for anyone who doesn't know exactly where this is, because there's a lot of context here. I can pull up the GitHub page for this project we're in. So as the tag says, this is an FPGA-based emulator to help you guess file names that the firmware might find interesting. And it's based on these two other big projects, this system on chip called MySock, which is written mostly in Python with some other components in Verilog, and then this Project Vault based SD card emulator, which I'm using largely unmodified, except that I totally hacked it up to add SPI mode support because I needed SPI mode, it turns out. And then it has some additional goodies so that you can have hardware timestamps and triggers that are perfectly lined up with the beginning and ends of SD card transactions. So that's where we're at. And this subdirectory here, flipsyfat, is actually the Python module that includes all the source code and everything. And then, why don't I actually open up a real text editor here? I find it so convenient having this now like all-in-one virtual machine with all of these tools that I need. And it would be easy. It would be nice if I could just like give this to people to help them get started with this same setup. But both the copy of Sublime Text and the Xilinx software is all like licensed to me, so they would probably find some way to hunt me down if I did that. Anyway, we don't want this whole thing here. This window is the one I wanted. So we have implemented in Python the actual hardware modules. Like this little page of Python code is the hardware peripheral, which implements basically a special purpose output that you can time exactly to the SD card transactions. So this is like everything you need for that. Likewise, this is like everything I need for the special purpose timer module. So this code creates a 32-bit free running timer. Here's a way for the CPU to read it. Here's a way, and this needs to be a little bit special purpose because the bus only has the ability to read 1 byte at a time. So there has to be a way to capture the timer's current value and then read back the value you captured. And then likewise, there are some other little capture machines that grab the current timer value when interesting events on the SD card link layer happen. And then this is the little reusable capturing machine that just knows how to update a counter when it detects a positive edge on a signal. So this would be really long if it was in Verilog. So I've been very happy with this MyGen stuff. And then the actual program we're running, I have a few different programs now, ranging from something that's very simple and just has a main loop that prints status periodically and then populates a root directory with file names that it generates with sprintf. So this is kind of the simplest to understand example for this program. But then I've also been really finding useful this other program that effectively gives you a text or a hex editor that's glued right onto the fat directory entry and then repeats a bunch of copies of that so that you can just edit that in real time and see how the system responds. And so that's also pretty small because it relies heavily on code that I've tried to make reusable. And then, so that's like the actual source code that you'll find in GitHub. And then this other directory, which is what I really needed to make this work without having to recompile the whole thing on a VM with this 30 gigabyte Xilinx toolchain, was this directory here. And actually, the portions that I need Xilinx for, I don't actually need for the software. I probably could have gotten by with just all the Python stuff. But it was still a bunch of dependencies, and it was probably easier just to copy over the whole VM. So here we've got the actual Verilog code that was generated from the Python, which is not something I would want to read for fun, but is less unreadable than I would have expected. And then we've got fun things like generated header files in both C and Rust. So I don't understand any of this Rust stuff yet, but I should really learn because I've been looking for an excuse to learn Rust, and it seems like I've got a couple of projects that might fit in too soon. But so far we've been using this version where, for example, if you wanted to read the timer that I added for the SD card, so that would be SD timer underbar. Where'd it go? I felt his legs on my legs. So then I would have had like read timestamp. So then the Python scripts automatically allocated that register and give me a little wrapper function that reads it in 8-bit chunks and reassembles it. So then the actual experiment we've been doing is a little more complicated than those really simple examples, but not too much. That one is called word list right now, and it's basically got a FIFO queue, first in, first out queue of experiments that it's running as fast as it can. And the queue is because I kind of need to have, like, to make it easy to populate the queue, I have it set up so that, this is the main file. All it does is it sets up some hardware, and then it repeatedly figures out what might be a good file name to try, and then passes it off to this guess file name function. And that then, in the background, does everything necessary for submitting that guess to a queue that can then be handed off to the SD card emulator in interrupt context, and then matching up the timing results that it measures with the experiments those timing results were responsible for, and then logging the results once it actually has them. So, and I let this run with a shorter version of the test first that just went through uppercase ASCII characters, and that one didn't find anything interesting. So this one includes basically the bottom half of ASCII, everything from space to backtick. So this one will take a little longer to run, and this is the one that was running overnight when my laptop stopped logging it successfully. So let's get this started again. I think it should be as simple as going into the directory for that software, there's word list, and then let's save the old log, start a new log. So now we have that TypeScript file that's just recording everything that goes through this terminal. You won't see it update until it hits a block boundary, but we could tail it in a separate terminal. Let's just stay here for now. So I think I just need to do make load. And then, oh, I've got to go over there and poke the reset button to get into the bootloader. All right, well, now the experiment's running. You can see we're still getting a bunch of those. So I mentioned on the last stream briefly how this worked, but basically that main loop that we just looked at is generating all these file names that it tries, and then in a combination of the interrupt handlers that are actually generating the file system blocks and the kind of coroutines that run inside that guess function. They end up giving you all this other output where we've got these periodic status prints where the lines that start with trying, that's just telling us what the latest guess is and giving us a bunch of other status, including these are like the number of SD card blocks read and written, the last read and write address. These are some status bit fields that mostly only make sense if you look at the Verilog code, but that 2 means that it's in SPI mode. The last command that it's seen. Yeah, and then these unusual results, these are when, so it's actually measuring the time in a really reliable way. It's using, so the actual device under test, so in this case the PLC that we've bricked and we're trying to recover, that is running off of so just like with this one, I pulled the oscillator off and it needs an external clock signal. And in this case, I'm generating the clock on the FPGA using just like a divide by 16 from the 80 megahertz system clock. So in that case, I can very reliably time the beginning and end of the SD transactions and get a pretty repeatable number that only differs by a handful of clock cycles, basically within the limits of that clock divider. So that the clock divider will give me a little bit of an unpredictable phase in some of these commands, and so within the limits of that phase difference, which is like 8 clock cycles, I get pretty much exactly the same result. So this is filtering out all the kind of mundane results that are the same thing that we would always get, and if it's an unusual result, it holds onto it and tries it again. So the rep equals 0 lines are where it's seen something once and then it's trying it again. And you'll see those kind of recycle through the queue. It maintains a FIFO queue that is usually about half full with guesses from that main loop. But if it sees something unusual, then it'll kind of asynchronously, in that coroutine, throw it back into the FIFO so that it gets another chance. And so that's why you might see the FIFO rise above half fill level, is when we're getting a lot of retries. So then if you see something with that rep count climb, then that means it's actually consistently giving us an unusual clock cycle count. So then the other thing that's weird about this is that we're seeing just some failures here. Like these cycle counts are not correct. So I set this up so I could look at the relevant events on the oscilloscope to see whether this was, some of these deviations that are a little bit higher than usual could be explained by an infrequent interrupt happening right when we're doing the processing. But stuff like, negative 26 million clock cycles or like 800,000 clock cycles, like all of this looks a lot like there's just something going wrong as it's reading the timer and the timer is just returning the wrong value, or, it's also a similar symptom to what would be happening if the hardware was updating one of these timers as we're reading it in 8-byte or in 4 single byte chunks. And as far as I can tell from the timing of all the events involved, that shouldn't be happening, but I obviously haven't gotten to the bottom of debugging that yet. But thanks to the system where it automatically tries things again if it sees anything suspicious, then that just means we have a lot of noise here where we have low rep count, unusual results. But if we actually had a result that was legitimately unusual here, then, so like for example, so I saved this old log from a lot of previous experiments. And if I grep that for a rep count of like 10, and so it doesn't get stuck if it just keeps, it caps the rep count at I think like 64, just because I didn't want this, if it gets a hit, to just like completely stall the experiment. But if I just search for anything that's reasonably high and not above that cap, then I should see them in the log if I'm actually getting hits. So for example, here you can see my control experiment. So I may have mentioned before that I did a control experiment just to make sure that this stuff was actually working. I think these really early ones were actually a broken version of my control experiment. But then later on, you can see the control experiment working properly. And here it's actually logging a high rep count unusual result every time the file name starts with D. So we've got DA, DB, C, D, E, F, G, etc. So that means that it is actually finding all of these unusual things that I've stuck in there. Here you can see one where the particular result that it's chosen to report also hit that software bug, but then it happened to be high rep count because of these legitimately unusual values also. Yeah, you can also see here, this is some other experiment that was going wrong, but these values that are like 2878 or so, those are all the control experiments showing a stable clock cycle result for this particular file name. And that was because the way the control experiment worked was if the first letter is D, it sets another bit, in this case the volume label flag in the directory entry, which we've already established will be checked before it looks at the file name and give us a different clock cycle result. So that was like the closest thing I could find to a loopback test where we tested as much of this as possible without actually knowing the real file names ahead of time. And as you can see, this, like, it kept logging a lot of other stuff after this, but nothing except the control experiments actually worked. So hence why I'm running this with the wider swath of ASCII characters now. So yeah, as you can see, a lot of these file names don't make any sense now, but I'm just going to let it run since now it can be pretty much standalone. I can just let this VM hang out and log stuff, assuming my VM doesn't crash, but this is now running on like a Mac Mini that I have set up so it doesn't crash when it's running long experiments, hopefully. And my TypeScript will steadily grow as I hopefully don't spill my coffee all over my desk. And this logs all my unusual results. So let's put this VM in a window and minimize it for a bit. Great. So now that that experiment is going, I think the next thing on the agenda is to open some mail. I actually have two packages today. One is a stream-related gift from Kyle, which is going to have some goodies in it. I think mostly a spectrum analyzer and a thermal camera and maybe some other things. It should be exciting. Let's see. And then I've got something from work, from Senryo. And actually, before I leave the computer, this is actually related to something that actually has a website that exists now. So we made this, I made one of the videos on here, but one of my coworkers, I don't know who exactly, made the website. And so basically, if you go to hackawebcam.com, then it has a little blurb about this. And this is the thing that I did earlier on the stream. Oh, this is the huge tip. Yeah, the huge tip. Over a wire transmit out. Okay. But yeah, basically, so I sent out all of these cameras back to them, since I think at the time they needed them for something, and but I'm actually going to be filling in for one of my coworkers who's going to be in Australia at the time, and I'll be helping out with running this class. So to prepare for actually running the class, now I've got one of the cameras and some of the other hardware back, I think. So let's go back to the camera. Man, you are such a cat. Well, let's open this one first, since I think this one will be a little more predictable. Do I have a card in the camera? I think not. I did, to satisfy some of my own curiosity, try plugging the SD card emulator into the camera. And it doesn't get very far. I didn't look closely enough to determine whether it's a protocol problem or an electrical problem, because the wiring was a little dubious. I had to use a really long flex cable to get my board attached to the camera's SD card socket. And then I just jammed something in the sensor that would normally turn the camera off when the door opens, so that the camera could still operate with the door ajar. So, you know, mechanically it was dubious. I did manage to get it to talk to a card over most of the same wiring, which I did as a control. But, you know, that still doesn't tell me for sure that my setup was electrically sound, because I didn't look closely at it with, like, the scope. But, do I have enough room on the desk to do this on the desk? I've been relegating mailbags to the floor so far because the mail tends to be bigger than the available desk space. Let's do that. All right, we are servo AF. I think we need to format this card too. Yeah, so I hadn't determined whether it was an issue with the electrical environment of the whole thing, or whether it was a protocol issue. From what I did see, it was getting a command 0, which is like the initialization, but I don't think it was getting much further than that. I think it was getting to the point where it would have been reading the card identification register. So it might be that there was something in there that it didn't like, so maybe it needs a card that supports some kind of high-speed class that I wasn't advertising. So, yeah, that might be something to debug. I didn't spend much time on it, but it might be that with not a ton of extra work, I could get this emulator to be a very slow storage device for digital cameras. And then with some additional work, you could have some hardware acceleration for, you know, cached sequential block reads and writes, which would maybe make it fast enough to use for actual video storage. All right, where's my knife? Here's my knife. Did I open that enough? Maybe not. Maybe this needs more knifing. Let's get that more in frame. Yay! Some of this looks familiar. Oh, yeah. So they sent it back to me with less packing material, which is actually kind of nice. So yeah, this is one of the same cameras that I modified earlier. Still in good shape there. So this is basically one circuit board here that has the same kind of system on chip you'd find in a Wi-Fi router, and an image processing chip that's basically the same thing you'd find in a webcam. And it's an all-in-one little unit that also happens to have a serial port on it that gives you a BusyBox shell. So that's actually just going to be the starting point in the workshop. There's, you know, you kind of start out by hooking up to the serial port, but then it's like, well, where do you go from there? And a lot of it's about that, and kind of giving folks a taste for what you can do once you've actually got a shell on a system. So, yeah, epoxy and Kapton tape, pretty versatile. So we'll hold on to this. And then, oh, here's just all the garbage that came with, sorry, all the stuff that came with the camera that I don't actually need. spare Ethernet. I didn't even take this stuff out of the box when I was modding the camera, so I don't even know what's here. There's a adapter. I think this is a... The other thing I was expecting was a bit of the test hardware that we're using to poke at the IOs. Yeah, this is something else that the folks at Exhibitor make. It's the Shikra, which is basically kind of a FTDI/JTAG doodad that some of the experiments use. And I have some stuff here that is similar in functionality, but I don't think I had actually exactly one of these here, so I wanted to make sure I had the same kit that the students would have so that I could try the experiments and get up to speed with them before we actually do the class. Get a slightly closer up shot of this. So yeah, I don't know a ton about the feature set of this board, so I mean, it's an FTDI breakout basically, but I guess what I mean is I don't know a lot about what the software that is usually run with this board usually does, so that's part of what I'm going to be playing with in the next couple days. But I think it's similar to something like a like a GoodFET or like a Bus Pirate. Just one of these little doodads that you can use to break out signals over USB and play with them. I had my own version of that I made years and years ago. When was this? This was 2001, maybe 2002. I made this thing that I called the remote-controlled pick of doom, or the RC pod. And I designed it mostly because we had, I was helping out with this, well, helping out. They were paying me, it just wasn't enough to actually survive on. I was, this was like, I was a student, and while I was doing my studenty stuff, which was mostly ignoring classes and working on my own projects, yeah, that was fun. This was an on-campus organization called Space Grant, which was, I think, mostly funded by NASA. And the basic idea was, they ran a bunch of these little projects where a combination of industry professionals for some value of each, and staff members they had, and students, both kind of fleeting students that would just like drop in for a semester, and students like me that just kind of made it their home. And then so they had some students who were also on payroll, which was me and a handful of other folks that I ended up becoming pretty good friends with there. But yeah, I think I was getting. I think I just like spent my entire, all my waking hours in that electronics lab there. I know this story had a point. Oh yeah, remote-controlled pick of doom. I was building, this was when I was working on like a replacement for, this was, oh man, okay, maybe this will be slight story time because this is I don't know, do I still have the source code for this project actually? Because that would be really funny. It probably looks disgusting, but is this even going to be like Googleable? I think I might know where. Oh man, it's hit number 3. The remote-controlled pick of doom. Yeah, so I mean you can read that if you like reading, but basically it's a thing that I built, way pre-Arduino era. I think I started this in like 2001-ish or so. Anyway. I think the inspiration for this was I was working on like a controller board for one of these student-built satellites, and so I really needed to make sure that this hardware worked really well. It was replacing some old hardware that wasn't very reliable, and I wanted a way to do automated tests as I built this thing. So I made basically a regression test framework built around this giant rat's nest breadboard plus this thing that today would just be an Arduino, but at the time it was this thing, the RC pod. Yeah, there's a bunch of stuff here. And so it was all like low-level USB. It wasn't like a USB serial device. It was PIC16C45. And the firmware, I think, is all just terrible hacked up assembly based on that one awful example that Microchip released. Well, yeah, so I guess I have some files that are like completely separate from the Microchip example code still, but it's all still like assembly code. Anyway, that was a fun project and a diversion. But it's nice that the kids these days have the Arduinos and the good vets and all them. All right. Ooh, there's a notebook in here. Oh, okay. We have a camera installation guide. This looks handy. I think this is a donation for the TucoCam sensor package, potentially. This is a depth camera, and I have like an old Kinect, and I recently got a new Kinect. Well, new, but those are both really big, heavy sensors. So like I could potentially try to get some of the space with those, but I don't think, like if I wanted static cameras to cover the entire space, that would require like more than just the 2 cameras I have. But this might be small enough I could put it on the robot-y thing, which means that I could use it for kind of 3D collision avoidance and possibly navigation. So this might potentially be a replacement for the downward-facing rangefinder. That's interesting. What is this? Oh, wow! Oh, get a load of this. Oh man, I had suspected that objects like this existed, but I've never actually held one of these in my hands. It's actually a book of resistors of different values. That's hugely useful, because I don't actually have a good collection of surface mount resistors right now. I mostly just have specific values that I've ordered for projects. Oh, they're even labeled on the back side so you don't lose them. That's super handy. Oh, and capacitors. I think it's mostly resistors, but these go from like 15 picofarads. Oh man, up to a microfarad. And there's more spaces for me to add my own. Oh, that's so handy. Oh, super appreciate this. This makes me unreasonably happy. It's got a lot of space for little papers and stuff. Oh, that's great. Aw. Oh, I've got a note. Oh, that's really sweet. Well, thank you, Kyle. I'm glad that I can share what I can. And, oh. Oh, that's great. Well, I appreciate this quite a lot, and I suspect that I will be able to give this stuff a good second home. So that looks like the software for the camera. This is some padding, which I wonder if Tuco is into. Hey, Tuco, do you like this stuff? You are so sleepy right now. I'm gonna leave this down here and maybe focus you a bit more. All right, cool. What else we got? Ooh. Whoa, this is a circuit board. This has, oh, it's an add-on for the FPGA board I've been using. This fits the Papilio wing footprint, which has 8 data pins up here and then 4 power, and they make it rotationally symmetric so you can plug them on in different orientations. This would be handy as an add-on for my my little SD card contraption. So thank you. This looks really nice. It's 4 buttons, 4 LEDs on 8 I/O pins. Sweet. You're gonna come down and enjoy the bubble wrap, Tuco. That laptop fan is running, like Tuco put it into warm mode somehow. I bet he knows how to do that. Well, I suspect just by covering up the keyboard, he puts the fan into warm mode a bit. You joining us, Tuke? Let's take this stuff out of the box so that Tuco can't knock it over and cause havoc. Ooh, got a little case here. I think Tuco likes empty boxes full of packing material. Can we confirm this? Oh, he's investigating the other one still. All right. Using more packing. Oh, very nice. So I have not really used this on the stream or even off the stream super much, but I've got one of the Digilent analog discovery boards, which among other things I thought it would be interesting to use as like a USB attached data acquisition board. So it's basically a small all-in-one device that has kind of an entry-level USB oscilloscope and signal generator in an inexpensive package that's aimed at the education market. And this is an add-on that gives you real BNC connectors as opposed to just 0.1-inch headers. So this seems like it will be super useful. Awesome. Let's put that in a safe spot. Give this to Tuco as a puzzle. Tuco, do you want to figure out how to extract those? No? I think yes. I think he's going to do it. All right. Ooh. Oh. This is another Gadget Factory contraption. What is this? Oh! This is a Mega Wing. This is basically their shield kind of thing where they use all of the, so you can see that this is basically 1, 2, 3, 4, 5, 6 instances of the same footprint rotated 180 degrees, and then they combine them all into like an add-on mega board. I have another one of these actually, or not this particular one, but like, where did I put that? It was handy. Oh, here it is. I got the one that has VGA and some LEDs and buttons. And this is also kind of handy. I used this already to run some other people's LED or VGA code just for fun. Oh, and a little joystick. This is also kind of handy. Oh, and it has a little A to D converter. I don't have enough free I/O to also emulate SD cards while I have this plugged in. So I'd have to, that wouldn't work for this experiment, but it's fun to have this around for other experiments. So this one that Kyle just sent me, this has an SD card slot, which could be really handy for logging. These are all analog. So A to D, so these are analog inputs. We have MIDI I/O with an opto-isolator. That's pretty rad. So this is like for audio, for making FPGA-based instruments. That seems really nice. There's a little joystick. Oh, this is the RetroCade Mega Wing. Oh! So is there also video out, or is that... Because this definitely seems to have some good audio stuff. It's got these big old 1/4-inch audio jacks. MIDI in, MIDI out through, 16 analog inputs, micro SD card, text LCD, and then these audio jacks are labeled A1 and A2. Can't tell if they're both wired as stereo or not. And then the little joystick. Yeah, this looks fun. This looks like it's designed for making your own synthesizers and that kind of stuff, which should be really awesome. The Gadget Factory guys, the Papilio platform here, I think I mentioned before that so I mean, I've been using it with the MySock system on chip platform, but it also comes with this platform, I think it's called Design Lab, that's basically an Arduino IDE for building system on chips. And it has some nice cores that they make easy to use, where you basically can like drag and drop on like Yamaha and SID sound emulation cores. They've got like a sampled sound core with a module player ported to it. So definitely some nice ways to make your FPGA give you some good sounds. Tuco, is that a bolt? You're so chirpy. Ooh, what is this? Oh, I think this is the actual sensor. Or the depth camera. Sweet. Yeah. Well, that definitely seems light enough for my winchbot to deal with. Probably a lot lower power than the Kinect, too. Ooh, is it pre-opened? Nice. Sweet. Big ol' heatsink. I'm guessing it needs that heatsink. I'm guessing a lot of that heatsink is for the IR emitter. That's interesting. This is already interesting, actually. Even just, thank you for pre-disassembling this. So this whole chassis is this big ol' hunk of, mostly looks like cast aluminum. Seems to be minimally machined, mostly just cast. Oh, I need to adjust the cat cam. That's what we wanted. Maybe not the right time to be servo AF right now. Oh, was that? That was me turning off the stabilizer, which is right next to the focus. So, oh, this is interesting. So I think this is the camera with a really fancy lens on it for the IR pass. And then, well, so basically I'm expecting to see two pieces, an emitter and a receiver. I think this is a time-of-flight style depth camera. So I think that's the receiver. I don't know why it's bolted to such a, like it's definitely intentionally stuck down to that heatsink too. So I don't know whether that's because they need to cool it or because it's just putting out a lot of heat. I don't know how power hungry the time-of-flight receivers are, but I think this is the emitter, because if you look over here, there's a little doodad on a cable up here. I think that's actually a photodiode they're using as power feedback. So they've got like a laser diode or something in there going through some optics, and then I think the optics are spreading it out, and then this is sensing part of the divergent light to get an idea of what the overall power output is for regulation. Or maybe for timing synchronization. But yeah, that's a nice little package. I mean, I'm assuming the heat sinking is pretty necessary, and I shouldn't try to operate it without this. Although, you know, it probably wouldn't hurt to have a little bit of strategically placed mass on the non-camera side of the gimbal, so maybe I'll just try to mount this so that it's, you know, I use the mass to benefit the stability of the robot, and it'll probably do me just fine. So that's pretty neat. I'll have to try this out and play with both the image output and how much I can strip it down and mount it in robots. This is also some, so I'd also been thinking about, well, do I want the, oh, are you gonna go up there too, Go? Are you gonna try to find a way to mess up my experiment even though I moved it over there? Or are you just gonna try to find a sunspot? I think he's just trying to get in the window. Oh, Tuco pushed the button on the stream. Yeah, you can see his tail there. Anyway, I think the laptop's fine. Cool. Yeah, so I hadn't been sure whether the kind of cat portion, whether the like moving portion of the cat camera needed to have a Raspberry Pi on it, or whether I could get away with putting the Raspberry Pi or whatever computer is running it somewhere else. Because really that platform just needed to have the gimbal control and video coming back, and maybe some sensors. And whatever sensors I had in mind, it seemed like I could run those off of a small microcontroller just fine, and I wouldn't need a Raspberry Pi. And then the micro could speak either Ethernet or RS-485 back to some main thing. But if I'm putting a depth camera on there, I definitely want like a Raspberry Pi locally so that it can, I mean, the Raspberry Pi might not even be fast enough, so I might have to look at other options. I'll have to look at what kind of data format that camera produces right off the USB. All right, I think there's one more doodad, which might be the actual IR camera, or might be the actual heat vision camera here, the FLIR. I think we're going to use the knife for this. I think we can be servo AF again. Whoa, that's neat. It's a Fluorone. So it's like a chunky phone case. What is this little doodad? Is that... It looks like a hook that the phone maybe is supposed to slip into. And then this seems to have a lens cap. Oh yeah. And the lens cap also turns it on. Neat. I wonder if this works. I wonder if this... I probably have to take off my phone case. This phone case is starting to wear out, but it's still protecting the phone all right. So this might be a good sensor to, well, maybe what I do actually is if this works out for streaming, then I can use this for showing thermal camera stuff on the stream, and then I can hack my handheld one to repurpose that one as a shop-wide, like wide-angle cat finder. That might be the thing to do. So, probably going to have to go to the App Store for this. I would have thought that it would give me some kind of App Store redirect pop-up over the Lightning port when you plug this in, but let me give it another plug and then maybe try turning it on. Let's go back to the home screen, and then, I mean, I could read the instructions, but where's the fun in that? Let's try turning it on. Does that do anything? Light's blinking green. Oh, here we go, App Store. Great. That's what I was expecting it to do. Oh, Tuco's got a new perch. What a good cat. Doing all the good cat stuff. Fluorone. Can I get this streaming? Oh, I guess I need to turn on Wi-Fi. Wi-Fi on. Stream into the Streamy Bob. it's still downloading. Are you done or are you not done? Thanks for the indeterminate state. So we have to look forward to. This is not really the optimal layout for a phone vision. Let's see if I can make a copy of this for vertical phone layout. That'll do for now. What are you even talking about? Why would I do that? Do I have to turn it off and then back on? It's flashing green. Like maybe it boots up when you turn it on and then it goes to sleep if it doesn't detect the app in some amount of time. Do I have to plug this in again too? Oh. Oh. That seems to be working. I might need to give myself another layout for this that lets me use it simultaneously with other stuff. Yeah, that's interesting. So it's the same low-res sensor that the TG165, which I've been using, has. In fact, you can. The other FLIR is actually sitting on the desk next to Tuco. But yeah, I got some Tuco warmness, some more extreme audio equipment warmness. You can see how lukewarm my coffee is not warm at all. That's depressing. I'm gonna drink it anyway. You were doing the wrong thing there, phone. So that's interesting. It basically looks like it's taking the low-res image from the sensor, just upscaling it with a big blur, and then putting an edge-detected and maybe sort of aligned version of the camera image on top of it. Which is pretty handy. Like, I mean, it's kind of surreal, but it's also basically the visual information that I would have wanted. Hey, Tuke. Tuku, you have a cold nose. Why am I not able to download a thing that I don't want to download? Yeah, is there a way to make the enhancement go away just for reference? I mean, I guess I could just cover up the lens on my camera. Oh, it's using its own camera, of course, because it wants the lenses to be close by. So that's what happens if I just put my finger over the lens for its camera and we're just looking at the heat image. And there's its calibrated image. Oh, Tuco found a bolt. Hey, Tuke. You want this? I mean, the other thing about this sensor being pretty low frame rate is that you really don't notice any of the Wi-Fi compression artifacts or anything like that. You can tell it's a warm day out there. All right, this is fun. I think this is definitely going to be making more appearances on the stream, and the TG165 might be a great candidate to hack and use as some infrastructure for the camera navigate, or the movable camera navigation. This is the power supply for, is that the light or the camera? That's the light. This one's the camera. They're not actually that warm, it's just they're warm relative to everything else. Meow. You're such a cat. Oh, bright spot above the bathroom is the Wi-Fi router. Bright spot in the kitchen is the hot water boiler. We've also got a little wall wart, which I think is running. Well, there are two wall warts, plug-in adapters over there. One running the Evil Mad Science bulb dial clock, which is on the stove and not producing much heat, and the other is running a network switch, which is on the other side of that wall and probably would be warmer if we could see it. Hey, Took, where's the bulb? I didn't see where you dropped it, honey. Did you put it in here? No. Tuco, I don't know where it is. Okay. I think we've still got one item here in this little case. So let's see what that is. If I can pry myself away from this fun little device. Oh, can I do screenshots here? Is that going to work out? Hey, Took. Oh, there's your bolt. Let me give you a bolt throw and then maybe screenshot this. Seems to work. Oh, and how good is the temperature reading here? Why is it asking me to do that? Oh, I see, that's a manual shutter. So it just tells you, please move the shutter, I need to recalibrate. Nice. Hey boy, you have a warm face. All right. Well, that's fun. Let's go back to the other camera. All right, so I think this is the last doodad from this amazing haul. Nondescript little case. Ah, yes. This is the big thing. This is the spectrum analyzer. So this was just an extra spectrum analyzer that Kyle offered to send me, and I was super excited about it because although I now have this amazing oscilloscope in my lab, I still don't have like a proper spectrum analyzer. I can make do with FFT on the O-scopes or with an RTL SDR dongle, but this was something that he recommended, and he had something that he wasn't using, so it's a little handheld spectrum analyzer. Do I have any antennas I could just plug into this right now? It's got a Wi-Fi analyzer. So I haven't actually looked at the instructions for this to see what what the software is like or what the capabilities are specifically, but it looks pretty nice. Battery status. All right. Grab an antenna. What do we have for inputs? Are these regular SMA? We have 2 SMA jacks. Oh, this is a Seed Studio project. Nice. So, I don't know what this is. I'm going to try using this one because it's the actual one labeled RF 50 ohms. This might be an output or something. I have to check the documentation. There's like a 3G, 4G antenna with a 50 ohm not reverse polarized SMA, which we could try. And we'll need to scan a different range for this to work. Everything is very weak here. Might have to read the instructions to understand how to set this up correctly. This looks like receive bandwidth, center frequency, spread. Oh yeah, spread. So we're just around 2.4 gigahertz, which is why we're not seeing much. Can we type in the new center frequency? Ah, yes. Oh man, what is the center frequency of this off the top of my head? Let's look that up. Not that. That's Apple stuff. Let's go back to, while we're here, we can check on the VM. This keyboard. It is up to Zan Space. What a great file name. Reset 748 times. 200,000 experiments so far since we just started it. All right. Oh, 18 megahertz. Or 1.8 gigahertz, I mean. Really, I should be looking at the specs for what this antenna covers, but I think I just got this as something sold for use with cell phone modules without like a full data sheet. Oh geez, none of this is what I want. Go away. Let's just see if I can find something around 1800 megahertz on here. This is a cute little package. I'm sure once I get used to the UI. So, what can we do here? Frequency span can go as high as 600 megahertz. Why is this start and stop frequency not updating? Oh, now it is. Okay. Oh, okay. So it looks like there are a couple of different hardware inputs. There's like a wide band. What is this? So 15 to 2700 and 260 to 960. So there's like a wide band and a narrow band front end. Oh, did I just cancel all the settings by pressing return? Yes. Oh, attenuator menu. Okay. Neat. Am I adjusting the scale now? I think I'm boosting the scale. Maybe not. I think the signal is still too low for this to pick up, so it might need either a preamplifier or I might just have the attenuator set up wrong. So anyway, I'm gonna have to look up how to use this properly, but I appreciate this. This is going to be quite helpful for the RF experimentation. Sweet. Well, I think it's about time to move this stream into the next phase, which is putting tiny wires on circuit boards. Oh, actually, that's a really good suggestion. Deadbug Engineering in chat is saying, don't turn it on, take it apart, or at least take a look inside. Actually, that's a really good point. We did look inside the camera, and this looks pretty easy to open, so let's give this a really brief teardown. Do I have the right screwdriver handy? I think it is elsewhere in the room. Let me grab one. Oh, geez, the people are working on the roof right outside my window. So I think this is going to come off, this is going to come off, and then the whole circuit board is going to slide out that way. That's my hope. Yeah, Tuco's like, what's that drilling noise? I'm like, Tuco, it's a power drill. I can't quite tell what they're doing. At first it looked like they were repairing the roof, and now it looks like they're painting. Maybe it's both. Oh, Mike in Mike's electric stuff is in chat, and he's pointing out that I've had the antenna in the wrong socket. All right, well, cool. I'll have to try that after I put this back together. I suspected it was something really dumb like that. On the bright side, without any antenna connected, it seems pretty quiet on the spectrum, which is good. All right, just basic plate there. You can already see LiPo battery and like a spacer, and then the main circuit board with some good old clicky tack switches. Oh, and the case actually comes apart in two halves here, so I think actually I want to take these screws out and then just take the front off, and then we can see the circuit board. Tuco's got a good spot keeping the computer warm. Cute. Might not be able to see a lot without taking this board out. We can see the designer's signature there. Ariel Rochel. this is all just user interface stuff. Well, this looks straightforward enough to take out. We need to take out these 2 screws because this panel needs to come off too. And then the 4 on the circuit board. Oh, those aren't tight on the SMAs. That's interesting. I wonder if that was from this being apart before. So that is the backlight. And the battery is this connector, which we can't quite get to yet, so we'll just have to be careful not to short it out. That is too big for the screwdriver. Big screwdriver for these. Yeah, those 2 pins are the battery. Right next to the screw that's got to come out before the battery does. That's a little unnerving. I always like to have a way to have a battery disconnect while the product is mostly assembled. I'm glad that SD card guessing experiment's running so fast. I still don't know if it's going to give me the results I want, which is partly why I've been already switching back to working on the other PLC. But it at least is running fast now that I'm running 1 experiment per block in the root directory. And I've also made the root directory as large as I could without crashing the firmware, which apparently is like 4,096 files, I think, before I start hitting limits somewhere. And I haven't checked to see whether it's limits in the firmware or limits in the FAT spec. Oh, we just lost a washer. Oh, these are insulating washers. Why does it have insulating washers on 2 of the standoffs? Just these bottom 2. Alright. Does this come off now? Alright, the battery is staying, the board is coming. Can we unplug the battery now? Oh, why are all my tools way over there? I still don't quite know the least damage way to get these connectors out. This looks like it's latching right in the middle of that pluggy part. There we go. Battery disconnected safely. Now we can start to see the goodies. So on the front, just UI on the front. I don't know if you can see the buttons, but if I take one of the caps off, you should be able to see what kind these are. It's basically the same, like, big, I think they're like 6mm tactile switches that you find in like chunky Arduino stuff. And then on the back side we have a plug-in board. Oh, this is already loose. Oh, I see. So this board, this is going to the main board, this is going to the mezzanine board. So whatever I was doing before, I was just totally bypassing the antenna amplifier front end thing. So maybe this is IF and this is the input. So yeah, definitely the wrong connector. And taking this further apart does mean taking off this plate. Yeah, I mean, Dr. Toon in chat is pointing out that the FAT32 spec maxes out at 32K files per directory. Yeah, I hadn't checked to see at what layer the limitation was, whether it was at the FAT16 layer or whether it was the firmware or some problem in my implementation. At that, I mean, once I'm getting to a root directory that big, then like I'm already amortizing out the cost of my reboots over a lot of experiments, so it turns out to not be so bad. Are you really that not servo AF? Okay, cool. So let's take a look at the main board first. Oh yeah. This has 2 radios on it. Okay. So this antenna, or this port is an antenna going to a totally separate module here. Trying to read that off the viewfinder. You can probably see that at home better than I can. SI4313, I think. I'm guessing that's either a system-on-chip radio or some kind of clock generator, but that says ANT, like antenna. So I'm guessing this is some self-contained radio-on-chip module that they're using as one of their radio paths. And then over here we've got a PIC 24F. Can't quite read the rest of their part number from over here, but maybe you can at home. And I assume that's a USB serial. Yeah, Scilab CP2102. I'm guessing that's a power regulator. Alright, so this board is interesting. What was this again? Yeah, SI4313. And this also is labeled RF Explorer. This is RFEW, or EW sub 1G. Alright, then we have another radio module over here. Ah, expansion module. Focus. Neat. It's not actually labeled as to what kind of expansion module it is, but they've got a nice silk screen for this. Mail header in this side. Great. Okay, so this has RAM expansion, flash expansion, and another little radio module. Which one is this? Another Scilab's chip, and then RF. I would really be doing this under the microscope if it was going to be a proper teardown, huh? RF 2052. It's the crystal. Can't tell what that's actually rated at, but that's neat. A little balancing transformer. And then SI4330. Alright, I'm not going to go into a ton of detail on this right now since I clearly don't even know how to use this thing, but I will read up on it and probably see it in a bunch of future streams. think it's about time to get this back on track and work on the work on getting this experiment up and running again. Let's quickly put this back together. That battery's got a protection circuit. I'm about to put this back together without the expansion board. That would be sad. Let's not do that. Definitely some scraping on the roof happening. All right. I already lose one of the little paper washers. Oh yeah, just checking in chat. Phil noticed I was about to put it back together without the expansion board. Yeah, I appreciate the thought. I'm sorry, I was too spaced out to notice. I am probably about to put it together without one of those washers, but maybe I don't care. I put the one back on the side that was right next to the battery, if that even matters. Oh, here's the other washer. On the floor. So we could at this point turn this on and make sure it sees the expansion module. Yeah. Oh, I see. It was trying to tell me which input to plug the antennas into, but I didn't understand that that's what it was doing. Yeah, okay. Great. Yeah, this is the screen that was relevant that I did not understand when I saw it before, but that means that it's looking for something over here. Is it gonna, oh wow, that's a lot more spectrum than I had last time. Yay, it helps have an antenna plugged in. I might need the attenuator at this rate. I'm just stepping it up in terms of the scale, I think. Well, that's neat. Can I have cursors? No? I can change the center pretty easily, though. I think that's what I'm doing. Oh, it's telling me a peak? It was telling me a peak. Now I don't think it's identifying it anymore. Anyway, I'm going to have to learn how to use this UI. It looked like it was briefly identifying this peak and trying to tell me about it, but I didn't quite get how it was doing so, and which of these numbers was relevant. See, like, okay. That's a little nicer. Now it's not saturating against whatever. Was I holding this next to something that was producing a bunch of interference, or was that just set up? Well, whatever I changed is now producing a much overall quieter spectrum. I'll have to try this with some known sources of RF so that we can see what that's like. So far, you can at least see it disappear when you disconnect the antenna, which is a good sign. All right, let's put this back together. That's the right orientation. Stay in there, little guy. There sure is some construction happening. Mikey in chat is suggesting that I should give it an hour or two, and then I can take my new FLIR cam out on the roof and then tell the painters on the roof how hot they are. See, the first problem with that plan is that I can't actually get out onto the roof here, at least not on the part that they're on, at least not without them calling security or something. I think there's part of the roof here that some of the tenants have keys to, but I don't have those keys. I think we went out there on 4th of July a while ago and got to see some fireworks. There's something satisfying in some ways about having a doodad like this disassembled, because then it's like so much less work to hack on now that it's disassembled, but then it's also less convenient to actually use. It's always the trade-off. The buttons feel a little lower profile than maybe they should be, but I think maybe that's how it's supposed to fit together. And now I can see why these nuts are loose. That would be probably a good state for them to hang out in. Okay, cool. This will be the subject of much future experimentation. But for now, let's get back to the task at hand, which is hooking up this PLC for glitching. Oh, did I finish my lukewarm coffee? I didn't. I still have lukewarm coffee. What an amazing thing. Oh, that's a great idea. Emily in chat suggests taking off the RF Explorer shell and then powder coating it some badass color or pattern. That would be super fun. I feel like I could almost pull off powder coating even just here. I know there are places nearby I could do it. I have one of the little high voltage powder coating guns, which I actually got a while ago just as a easy high voltage power source, but I could still use it for its intended purpose. I think the thing I'm mostly missing is the oven to bake the parts in, but if it's something small enough, I could get a spare toaster oven and use it for that kind of thing. All right, let's put some of these goodies aside, make some room for this experiment. Oh, actually, I should grab the other pieces that go with this experiment. That is this contraption. So this... There's a guy hammering. I can see his elbow from here. You can see just a hint of orange safety vest through the plastic they put up on the window up there. That's where the folks are working today. And dropping tools, as you do. Okay, this is the experiment again. So we have the Raspberry Pi and microcontroller that are responsible for our underclockable Ethernet setup. Then we have the chip whisperer, which we're using for timing the fault injection and generating an overall clock signal. Whoa, there's a really tiny bug on this. Where did that go? Look at that. Where did it go? I crawled underneath, but I was it was just in the microscope field of view. There was some kind of tiny insect on the wood. Anyway, so the insects are not part of the experiment. I don't think they have much effect. But most of this is powered off of 12 volts. Chip whisperer is generating the clock signal and the glitches and the reset pulses. What is this wire? So this is the clock, which goes to another FPGA, which converts it a bit, and then this is my wiring harness that I designed for the previous board, which I should probably try to be compatible with to make things easier on myself. And I'm just forgetting what this orange wire was for. It is connected to another, well, we can check what the pinout of the chip whisperer says this should be. Because I don't remember whether that orange wire is important for our current experiment. If it is, we want to make sure to include it. Oh, let's put the other cameras back up. There we go. Does this have the thing we're looking for? I know this document is outdated, but it still has the best Google juice for the connector I want. This is the connector, this 20-pin contraption. I think I need to get my bearings on which side is even pin 1 here. So I've got clock output on HS2. Okay, so that's the white wire over here. That is, so this cable right here is that white wire, HS2 and ground. And this yellow wire is, I think, 16. Okay, yeah, that's the trigger input. That's just going to the FPGA where I'm generating the trigger pattern, but it's also broken out over here so I can trigger the scope with it. Then the mystery wire should be target pin 3. Am I using that for reset? Maybe that was supposed to be connected to this transistor and I lost that wire. Okay, I'm going to assume that's something reset related. Actually, I should check to see if I have the software configured to use that. That reset line is actually important in this experiment. Let's open up another VM. Oh, good question from Deadbug Engineering in chat. Do you plan to add a VCO to be able to change the clock frequency more smoothly? That's a good question. I started down that route, and I even went and found some VCO modules on eBay just to have some stuff like that in stock to play with. And I had started planning down that route, but I think at the moment I'm just going to run the experiment kind of slow and steady so that there's just very little chance that I brick it in the same way. Because I don't think the experiment is necessarily going to be that slow. I'm just going to let it run and deal with it. I think the savings was something like getting from like 6 seconds per experiment down to like 2 or 3 seconds. So it's a big savings, but not necessarily worth putting in a whole bunch more engineering work if it's something that I already think is probably in a working state. It's certainly something to keep in my pocket for a future change, but I don't know if it's quite the time for that yet. Such a good cat. We got some high-quality catting over here. Alright, so here's my VM. I think if we just open any of these, we'll see how I had it configured. So trigger is on target IO4, which I think is consistent with what we were just seeing on the wiki page. Yeah. So that would be the yellow wire in my current setup, which is going to the FPGA. And then, well, the other FPGA. And then GPIO toggle. So this is my reset toggle. I was using the general purpose GPIO toggle module in Chip Whisperer. And, oh, yeah, I guess it was still slower than 2 seconds. It's got a delay here of 4.8 seconds per iterate or per run, which is like, but it's fine. I'm gonna have to make that even slower. So the reset output was target IO3, and this is intended to go through a transistor so that it's, when this is high, then the transistor is pulling the reset low. So target IO3 is, I think, my mystery wire. Yeah. So I think this goes to the transistor. Oh, gotcha. Yeah, now I know it. I know the story behind it. There was another wire that connected this to my breadboard over here, but then I repurposed that wire to go to my oscope so that it could generate that signal. And then I think I took that wire away instead of putting it back when I took that part of the experiment apart. So this needs to go. I think it just plugs in like right here. I need a little bit of wire as a double-ended adapter so I can plug these two female adapters into each other. Do I have one that's the right gauge? This stuff is too thick. This stuff might be too thin. I really need to get some longer headers for solving this problem. I have a bunch of headers that just are not long enough to serve as connectors between two female headers. Let's just see if I can make this one work. Not the camera I wanted. There's still a couple of buttons that act squirrely on this controller. Either that, or I'm just misremembering which button is which. Maybe that's it. Maybe I'm just getting these two rows confused with each other all the time. Maybe I'm just blaming the technology when it's my own fault. Yeah, this wire is too thick. This is actually the kind of thing that like cut-off legs of resistors are perfect for. Let me see if I have a bin of those handy. Yeah, well, I've got a bin of cutoff bits, and I've got a bin of headers. So I don't think I have any, well, I've got some, but they're not especially great, like stuff like this. I think this is pretty much exactly what I want. Some wire that is thick enough to fit into these sockets snugly, but not so thick as to just not fit at all or to damage them. Yeah, that'll do. That goes to my reset trigger input, which is also going to this FPGA. I don't even remember why the FPGA needed this signal, but sure. I probably wanted to reset some state machine. I should take another look at the code that's running on this FPGA to make sure it still does what I want, because I might have something unintentional in there, which could be bad. I think I got rid of all the variable clock divider stuff that caused the thing to break, but I guess probably couldn't mill a scanlime into this, but I could certainly put a sticker on it. All right. So, where are we at now? We have... Yeah, I'm going to look at the FPGA code before really doing anything with this wiring harness. I want to mount this board where it goes. So we still have the bottom I/O board from the other PLC, which I didn't do much modification on, but I removed these connectors, disabled the backup battery supercap thing, and glued it to the board here. So this fits like so. Ooh, yeah. It even still fits in my little 3D printed holster there. So that's all nice. Before I can really mount that though, like I can do most of the wiring I need on the top here, which is, you know, why I went to all this trouble. I wanted to just expose that region. But on the bottom side, I still want to wire up my two kind of critical connections to the V-core rail. So these connections are really sensitive to inductance and noise. This one goes to the amplifier, which I'll be looking at the signal with on the scope. And this goes to the glitch adapter. So basically this is glitches in, this is side channel analysis out. And they both monitor the same power rail there, which I might need to add some extra filtering on the 3.3 volt side of that, but I can do that on the top of the board after I mount this all. So, oh, Fedora in chat says, ugh, single pixel resize borders. Is that visible for you? I see, I have that highlighted on here, but I thought that wasn't actually visible on the stream. I can make that go away by locking OBS. Wake up, mouse. Come on, mouse. And yet another reason why I don't want to use Wi-Fi here. So much wireless stuff just is not working in this area. Okay, well, if you were seeing a border, it should be gone now. Okay, so let's put this aside slightly to make room for a little more soldering. Oh man, I want more coffee, but I'm actually out of coffee. I'm gonna have to take a trip outdoors soon to replicate that. I will replicate that in time, but perhaps first I will remedy it. All right. Work holding is already becoming a bit of an issue at this point because this board is so weirdly shaped. Another reason why I don't really want to be working on the back of it if I can avoid it. Kind of just hold it by the connectors if I clamp it there with the stick vise. Oh yeah, let's also warm up the glue gun because I'm going to want some more of that too. I already took off some of the hot glue here because, well, so somehow, despite this being pretty much an exact replica of the rig that I had built before, this wire here ended up not being long enough. So I ended up replacing that wire with a longer one, which you can now see I've roughly trimmed to length. But I don't know what made up the length difference. I haven't gone back to see what I messed up there, but it was fine extending the wire slightly. I think I might just have the boards overlapping a little bit less in this mounting arrangement, but in order to make sure it wasn't just the wire being bent at a steeper angle off the board and getting stuck in the hot glue, I pulled off all that hot glue. But now that I've replaced that wiring, I want to put this hot glue back as a strain relief, and then also strain relief over the actual solder joint that I make here with a little bit more hot glue. So first I want to tin these wires and figure out which one is which and get them roughly positioned to length. Where's the cat? Didn't he just leave? I thought he was there before. Oh, let's have a grounding strap. Let's not be operating the grounding strap in wireless mode. Well, maybe this will be a good excuse to go take a walk and get a sandwich at some point if I need to break from the painting noise outside. Let's unwrap these by hand a little bit. So this is just heavy gauge magnet wire that I wrap together on a drill. It's mostly my attempt at making a cable that should do well as a kind of low impedance connection for short distances. The important factor being that the insulation separating the wires is really small relative to the wire diameter. I think something roughly like that, and then a similar amount of untwist on the other side. And then tinning, and then cutting to length, and then soldering. Yeah, having a VCO in general, back to that topic, would be a really nice feature to have for a general glitching board. I feel like the next time I set up something like this, I probably won't be using the Chip Whisperer Lite to run it unless I can kind of stay a bit more within its capabilities. Because I think in this particular experiment, a lot of what I'm doing is happening on other FPGAs and other tools, and so it might be worthwhile to... I guess I've just been really enjoying the system on chip in the SD card emulation rig and how standalone that's been. And I mean, basically, I can see a couple of different routes that I'd want to take this test setup. Either make it really small and standalone and use a separate FPGA to do all the work, and then have some code running on a system on chip that would actually be... Oh, hey, Tuco. Are you going outside? So there'd be some code on a system on chip that would run the experiment, and then... And the other route I can think of taking it is, for an experiment where I can't get away from needing a really nice capture setup, then I just design it to run with my oscilloscope, but then automate around that some more. So use Ethernet, for example, to automatically grab captures and then store them. Because, I mean, it's convenient to be able to do a quick experiment using just a time-lapse video recording of the scope screen, but having programmatic access to the traces would help a lot in other experiments. I think I untwisted that one too much, actually. I think that's roughly what I want. Depth perception fail. Alright, let's get these tinned and then figure out which one goes where. This is another one of those situations where I think I know where Tuco is hanging out and I could go chase him with the camera, but I think that the act of showing interest in him would then prompt him to complain additionally and try to go outside, which would be fine, but also seems counterproductive because then we wouldn't have the cat hanging out around here and I would be distracted. It does have the advantage of, the cat can hang out outside, which he might want, but he has he's very fickle about that. Like, he'll complain about it and he'll really want to go outside and then he'll go out there and then he'll be back in like 5 minutes and you know how cats are. So like, I'll do it when I can, but I won't necessarily stop what I'm doing and let him outside anytime. That's one of the differences between him and an actual dog. Burning off the insulation here. It doesn't need to be clean. Oh, I can hear him yelling in the hall like he wants to get someone else's attention. Let's just solder them all together. Hey Tuco, what do you want, little boy? Let's find out which one of these is which, and then get them cleaned up, both in terms of position and get them kind of fluxed a little bit. So ground should already be attached to both of these. Both of those. I'm not getting continuity on the other side. I'm doing this test. That's 0 ohms. That's 0 ohms. That's not a good sign. Let's try to separate these a little and see what's going on. Because that is weird. If they were actually shorting, then we would be seeing them shorted at that side of the cable too. So something is just strange here. Okay, I think I might have just been touching this one. So now that looks much better. So is that V-core? Can I get a good connection to it? Yeah, that's V-core. That's ground. Great. So that happens to already be roughly in the right position. I just need to angle them a little bit. Let's see what's going on up here. Ground on the left, so these need to be swapped. So basically untwist it half a turn. Let's be using tweezers that are less bad for this. This is pretty stiff wire. Might need the little pliers for it. This might also necessitate trimming that left one a little shorter. That one needs a slight trim also. And we should be able to test that the right side is ground on both of those. All right, and let's reapply solder and/or strip insulation to the left side of that. Oh yeah, a little bit of somebody in chat, who is this? Dead Bug Engineering was saying, I would sell my grandmother for a mantis. And then Dr. Toon says, you'd have to. What are they, like $10,000? Yeah, I've only seen those on Dave Jones' YouTube channel, but they seem pretty nice. Or actually, maybe Mike has one too, I forgot. Yeah, if I was doing more like really serious microscope work and I could get my employer to pay for it, then that would be really tempting. This one is just a really cheap, well, it's not that cheap, but it's like a little nicer than the standard USB microscope, and it's HDMI, so there's no USB lag, but it still does not have expensive optics. So this microscope I'm using right now was like $130. It's just like a kind of generic HDMI microscope. And it's actually been really nice, especially for the price. I've also got an optical microscope made by Amscope, and it's quite nice to work with. I just don't really have a way of sharing it, other than kind of precariously holding a camera up to one of the eyepieces, but then I can't use it at the same time. I also tried making an adapter for my DSLR, but that's also a little annoying to use. But yeah, I mean, it would be nice to have a microscope like that that also has a spot for a camera. I think I do appreciate how this microscope is something that is, you know, pretty inexpensive and relatively easy for people to get started with. It's a little nicer than like making videos that are supposed to be kind of, you know, accessible for a wide audience and still have, you know, just do everything with super expensive tools. I mean, I know I just recently got this really nice scope, but I do try to generally show people how to do things with the minimal tools possible when I can. The scope has been really nice for reverse engineering experiments. If I want to demo something where I want to intentionally show kind of a more entry-level scope, then I still have my trusty Rigol. And I also recently got an analog scope, which I haven't actually showed on the stream yet, but I had this Hitachi, I think it was a 50 megahertz 2-channel analog scope as a kid. I think it was something my dad found like at auction or something, and he gave it to me as a gift when I was young and starting out with electronics. it was super nice. And then eventually I ended up giving it to a friend, partially because I didn't really have room for it, given my living situation changing, and partially because I needed a scope with a little bit higher specs, and it wasn't really cutting it anymore. So that's when I gave that one to a friend and upgraded to, well, my next upgrade was actually a USB scope. I tried the Pico scopes, or not the Pico scopes, the bit scopes. I had one of those. And I still use it sometimes, but it's also not especially capable anymore compared to what I find myself needing. There's such a nice range of scopes out there today that you can point people at depending on their budget and needs and skill level. It's been nice seeing like the new lower end stuff from from Keysight. Just enjoying some of Mike's videos recently on those. Since it looks like they basically took all of their high-end ASIC and software technology and just put it in a kind of simplified package, but it still actually has like 2 analog channels, which both have more bandwidth available than they really tell you about, plus an external trigger channel that actually acts as a digital input, so that seems pretty nice. Oh, I think I'm going to tack this down a little bit, but I want more flux. A little bit of flux from the syringe, maybe. Oh, there's Tuco. He's way over there. He comes when I call him sometimes. Nice little booger of flux to work with. Oh yeah, that's a really good point from Benjamin in chat, who says, Micah, be careful not to pull the pads off that PCB. The stiff wires might do that unless you bend them just right. Yeah, that's, like normally for this kind of work I would be using much thinner gauge wire. This is just a situation where for signal integrity I think the thicker gauge is helpful. I haven't really tested that or done a lot of math to verify that, but it seems like it would be, and it shouldn't hurt. But yeah, certainly I could pull the pads off very easily like this, but partly I'm not going to be moving this around much, and partly I am going to be putting a little dab of hot glue like right on top of this joint to prevent that from happening. And I can easily get the hot glue off with isopropyl alcohol when I inevitably need to change this later. A little closer to that capacitor than I would really like. I just bumped this one a little bit. Just don't want to have too much stress, like mechanical stress, in these joints when they cool, you know. That was great, except for the part where the other one just completely lifted. I think that right wire is a little bit too long. I might be being a little bit perfectionist in trimming it, but I think it'll help. My wrist strap is on a little tight, cutting off circulation. Are they vacuuming the roof? No, that's a power drill. No, maybe that is a leaf blower or something. Oh, that is very much a shop vac. Huh. Maybe they're scraping off old paint and getting it ready for a new paint job. Can't quite tell what they're doing up there. That's not soldered either. This needs some more work. I mean, I could also switch to a smaller soldering tip, but this joint needs a decent amount of heat because the wire and the circuit board are both kind of heavy gauge right here. I'm gonna make sure these aren't shorted with the meter, maybe. Actually, that whole thing bothers me. I'm just gonna change the angle a little bit. I just don't want that so close to the capacitor right above it. Heat both of those up, and then just grab this whole thing and try to angle it back gently. Ow, that was a hot glue gun living up to its name. That, flux is getting pretty sludgy. I think that's a satisfying enough joint. There's a bunch of gook in here to clean up, obviously, but I think that's not going to be mechanically tense, and it doesn't have anything shorting either next door or to this capacitor. I think that's going to be all right. So let's try to do something similar over here. Okay, I think those are the electrical joints I want. Let's make this less of a toxic disaster zone. Wait, what was that? US Water Rocket says, I think the Siemens IP task force is breaking in. Yeah. Alright, so propanol. Little brush, little brush. Here's the little brush. Gently, gently with the little brush. Man, that sure does create a nice little pocket that's difficult to clean. Oh yeah, it feels really thick and gummy. Tarry residue from all that flux. I'm gonna mix it in with some alcohol, it should be easier to get off. And then make sure the alcohol is all off before putting the hot glue on, or the hot glue will not stick. Oh yeah, there's a question in chat about the bottle. Yeah, this is like a standard kind of chemistry lab wash bottle sort of thing. You can get them in packs with labels for all the standard stuff you might have around. I've got the distilled water and isopropanol ones here. I think I've also got one somewhere for, well, I got like a multi-pack with a few others that I'm not currently using because I don't have those solvents around. There's one for acetone, which I keep meaning to buy some acetone to fill. Just, you know, it's not really productive to order acetone online from, you know, at least in the purities and quantities that I'm interested in. And so I just have to walk down to the hardware store and bring back a jug of acetone, which I haven't done yet. I do actually live kind of walking distance from a hardware store. It's enough that bringing back large objects is super annoying, but I can do it. Like, I walked home with some plywood a while ago, and that wasn't too bad. Oh, maybe that's what I could do today. Like, I think I will need to get some food at some point. I could get a bite to eat near the hardware store and come back with acetone. Just getting a little bit from the left, but I think that was just a capacitor charging up. Now it reads like 100 ohms there and like 0 ohms there, which is about right. I would expect to get 100 ohms impedance from some of the resistors I just added. Alright. Let's blow all the alcohol off of that and then put some glue down. Oh, do I have enough air in the compressor for this? Not really. That camera's basically at the end of its wire. All right. That's all it needed. Hammer drill. The Tuco has the ability to walk outside and escape this pretty easily. All right, that should be plenty to hold that in place. So let's let that sit a little bit. Everything else should be on the other side. I think there's probably enough heat sinking on there that the glue isn't going to flow away immediately if I just turn this around in a sec to work on the other side. Let's get the rest of this setup loaded into the desk cache here. Put some of this stuff away. Oh man, it might be time, if they're gonna be hammer drilling all this, I might take a break and take a walk to get something to eat and then resume either on this or on the cat camera project. Alright. What does this need? It needs reset, it needs clock, I need some GPIO outputs. Alright, 12-volt wiring here. This is the trigger from the chip whisperer. Chip whisperer. Alright, I can't concentrate with this. I should just take a walk and get something to eat. I think Tuco's just hanging out outside. Does this stuff at least fit? That fits. That fits. Yeah, I can't take this. I can't concentrate on soldering tiny wires to a surface mount chip while someone's hammering and drilling right next to me. At least not while I'm also hungry. So, oh, that's a good question from Etienne in chat. How long can flux stay on a board before cleaning it? That depends on the flux. There are brands of flux called no clean that you don't technically need to take them off at all because they won't corrode the board, but they'll be gross and sticky and you probably want to clean them off anyway. So those, you can wait as long as you want, but it's going to be a sticky mess that you might want to clean up. As for the ones that you do have to clean off, I think it probably depends on the chemicals and the temperature that you're storing the board at and probably some other factors. Oh, Emily is asking, did I finish my ice-cold coffee yet? I did. I might have to, oh yeah, if I'm walking, I should go buy some more coffee beans. So, but they still, the guy is standing up there like he's still got a lot more to do. He's still holding the hammer drill. Oh, yeah. All right, folks. I think this is going to be the end of this stream, but I'll be back soon with more of this. How's our project going? If we could take a really quick check-in here. If I could figure out which mouse I need to hold. Holy crap, what did I... Sorry, this is not even related, but I really mangled this keyboard somehow. Again, not sure if I crushed it in some equipment or whether that was cat related, but it still seems to work. What do we have here? It is up to star comma y bang. Almost 2,000 resets. 500,000 experiments. Do we have any hits yet? I assume we wouldn't, because it hasn't really gotten to an especially interesting part of the search space yet. Let's see if we have anything at rep 5. Nope. Anything at rep 2? Some garbage. Yeah, but these are just that intermittent bug that I haven't gotten rid of, giving me false positives that go away after a couple of repetitions. So no hits yet, but the experiment is running along nice and quickly, so we can just leave that and let it do its thing. Oh yeah, and just for some more context, Emily's asking what this was about. And yeah, this is, so she's asking, are you fuzzing whatever it is doing a directory listing? Basically, I'm trying to find the file name that it's loading, because from the context and from some earlier experiments, what it looks like is happening is the firmware is either in some kind of bootloader or recovery mode or something like that, and it's scanning the root directory of an SD card. And as far as I can tell, it's looking for either a file or a directory. It doesn't seem to care yet because it hasn't checked that flag. And it hasn't responded to exhaustively testing all 8-byte patterns, so like AAA, BBBB, etc. I couldn't find anything where it seemed to be making more progress in its compare before exiting out. So based on all of those clues, I've been assuming that it's doing the comparison in larger chunks, like 16 bits at a time or 32 bits at a time. So for that, I upped my infrastructure here, and now I have this program which is much more quickly running tests on a lot of different file names with these different repeating 4-character chunks, so that if it's testing an entire group of 4 characters all at once, that one of these eventually will give me a hit. And to measure which one of these are effective, it's carefully looking at the timing between SD card requests as measured by the hardware on this FPGA system on chip. So that's what this is doing. If you want to know more, all of this is on GitHub if you search for FlipsyFat. It is a thing that I might write an article about eventually if it actually works, but right now it's just an experiment. Are we going to have a reprieve from this hammer drill action? Did I just need to calm down and do something else for a sec before table flipping? Maybe that's the case. Hey Tsuko, welcome back. Ooh, let's make sure to hide this window before I break it. All right. I hear you, little tiger. You're not in front of the camera, you're behind the camera. Do you want to run it? Do you want to be the camera cat? All right, well, I think one thing I need to answer is which of these clock pads I should be using. I might just cheat and look at the other board that I've already done. Looks like in this orientation, well, from my point of view, it's the bottom left. From that point of view, I guess it's the top left. Yeah. Anyway, let's get this under the microscope and at least wire up the clock and the reset. It'd be nice to get this thing to boot. because I have not seen this PLC boot yet. Yes, did not even test product before. I mean, I think I did turn this on a while ago, but I wasn't recording it or streaming it, and I didn't really do much to it. Let's see. Make a little room to get this under the microscope. Oh, of course, now that I was thinking about taking a walk and getting a sandwich, that's starting to sound good again. Clearly, I just need to plan ahead and have taken a walk and gotten a sandwich, and then just have this delicious sandwich sitting here waiting for me while I do the entire stream. No, wait, that doesn't sound like a good plan either. Is not great. It's not as bad as the drill, for sure. Okay, let's see if we can correlate this to the data sheet just to make sure everything lines up. But it looked like on the other board that I've already modified, the way I did this was I used this input, this pin, which should be the clock input to the processor, put some Kapton tape over the rest of this so I didn't short it, put down a surface mount resistor in series, and then connected that resistor via a little wire to my header with inputs. Let's just put a little solder in there to mark our place and then look at the pinout. So I think that's what we want. That is... I don't know how I would have done this to the cable. It looks like the kind of thing that Tuco could do, but I don't really want to blame it on him unless I've actually seen him do it. Oh. This one. Wake up, Lappy. Flicker, flicker, flicker. Okay. It's the microcontroller again. Pin diagram. So it's looking like the pin we're interested in is OSC0 here. I seem to remember this being confusing because a lot of chips label these oscillator in and out, so it's I and O. But in this case, it's OSC0 and 1, and I think in this case the 0 is the input, which is the opposite of how it would look like if it was an O. Let's see if we can confirm that. So OSC0 is our input. Great. So that's what, or well, that's for the other crystal, but I think they use the same naming convention. Yeah, OSC0 input, main oscillator crystal input, or external clock. So that's what we want. OSC0. And microscope. Oh, did I already put away my resistors? This is what I want. I need this capped on tape to be even thinner. So I just want to be able to stick a resistor on top of that without it shorting down to the other pad that's exposed. Let's switch to the little soldering iron. Oh, that's why the microscope keeps being out of focus. It's sinking because this doesn't have enough tension. Now it's too much tension to move. I think that's better. Come back here, little chip. And the magnet wire. Where's my magnet wire? My spool of little stuff is on the other side of the room. I only have my giant magnet wire here. I think this is the stuff I was twisting. That was 22 gauge. Huge. Yeah, my usual stuff is 32 gauge. Really like this stuff. Just cut off a hunk of this to use. Laptop is going to sleep because the power cable came out. Alright, let's just tin one end of this. Oh, I'm gonna start caring really soon where things are plugging in. Well, I think mostly... Oh, I had several grounds over there last time. Actually, do I have any grounds already? 'Cause I think if you look at this wiring harness, which is really just some jumper wires taped together to match the layout I had on the other board. So these two, this black and green, are both ground. This blue one is clock. Then green is reset. And yellow is... Yellow is currently not connected. I think it might be one of the GPIOs that I was using as a trigger output. So I don't know how much a lot of this matters, but it's causing me to realize that I think maybe some of these connectors that we were using mostly for mechanical, but also somewhat for electrical, that some of these might be ground. And if they are, then maybe we use those. And if they aren't, then maybe we still want some good grounds. So, get ground from over there. So I think one of these was actually a good ground connection. Yeah, that's 0 ohm. And so I think that was the bottom pin on here, which matches what I remember. Are these no connects, I think? Yeah. So this is our ground, which seems fine. I think what I did on the other board, and what I might do on this one too, is just solder another wire horizontally to replicate that across a few of these so we get some more grounds. Yeah, I'm just going to use that. Oh yeah, a little bit of chat in the chat that I haven't really been keeping up with, but I think we're talking about the big picture here. Yeah, so there's one question about whether there might be ways to glitch it during power up to enable flash or JTAG access. Definitely, that's something that is still totally on the table, but I haven't been doing that so far because it seemed like like reading out the firmware through this method. I mean, part of the reason I'm starting out by the glitch-based extraction is since that's something I had already done successfully on a different chip. It worked really well to get firmware out over USB descriptors on the one device I tried it on, and it seemed like that might be something that might be more generally applicable. Hey, Tuco. But yeah, it definitely, another approach to this would be to try to glitch either whatever, this could depend on actually how the debugging lockout works on the chip, like whether there's some kind of state machine or firmware that sets up the lockout based on flash contents. I haven't looked at it quite in enough detail on this yet to see how much of that process is likely done in ROM versus in dedicated hardware. And that would change a lot about how easy it is to glitch. But yeah, so far this method actually seemed to be going pretty well. Before I bricked it through what I assume was having a bad clock input that... So the bricking is still a bit of a mystery because I'm not actually sure what the root cause is. Like, I don't know whether it's some kind of damage to the chip, or whether it's onboard memory being written to, in which case, like why would it even be writing to the onboard memory? Let's make like 5 of these into, well, let's just cut off about that length and then figure out what that maps to. So yeah, there might be other ways to get the firmware out, but I'm sure there are, but there might be other ways that are even easier or more effective. But so far, on my test harness, where I was just kind of replicating this using some known code that I could introspect a little bit more, with that, I managed to get a dump of 64K of good firmware. So it was an HTTP GET. Well, I think it was technically a POST because I was using. Well, I think in my test harness it was a GET, but it will end up needing to be a POST because of my time reference strategy. But either way, it's an HTTP request that would normally retrieve a little fixed blob of. Well, actually, I just discovered it's not fixed here. In the real PLC, that blob goes through like a substitution thing. So they're basically like variables that can be substituted into the HTML, which is different from the proof of concept test that I was working on with the like kind of plain HTTP server example code. That was something I discovered just due to some of the glitches so far on the other PLC before breaking it. But basically what I got out of my test setup that wasn't running on the real PLC but was kind of a mock-up of it, I got a 128K response to this thing, which is usually just a little chunk of HTML. And the second 128K turned out to just be kind of garbled copies of parts of the the second half of that, so the second 64K.
Hello.
Oh, just a second. Hello, what's up? Hi. Yes, it's me. All right, thanks a lot. Hey, maybe we have some mail. Oh, these are motors. That's why it's heavy. These came a lot faster than I expected. I think these are from China. Smells like it's from China. I wonder what that actually is, like some kind of packing material that we don't use here. Oh yeah, these are nicer. I mean, they're still relatively cheap as far as motor goes, but they're a lot nicer than the ones I had. These should actually move my winch around pretty decently. Also, I don't want this weight on the robot. That would be terrible. That would be way heavier. These are definitely going on the floor. But I think these are in roughly the same class as like a car windshield motor, but what I was looking for, I think the specs I was looking for was roughly, I think my ideal motor would be in the neighborhood of 200 RPMs and about 50 centimeters of torque. And these came close to that. They weren't quite as good as I wanted, but they were well within the range of what I would accept. And they're also 24 volt. Ah, these are nicer. You can see these big old bearings in the back of the motor. A bit of a diversion from the current stream, I know, but yeah, that's nice. I'm not going to power it up right now because the supply doesn't even go up to 24 volts, but oh, there's the label from Siny Motor. This one is not very Siny. It is a little bit larger. But yeah, these should make a decent cat robot. I'll experiment with these shortly. Okay, oh yeah, so I don't know if I totally finished explaining this, but yeah, so I got a 128K chunk of data, and the low 64K of that was just a nice verbatim dump of 64K from memory, so that was solid. The next 64K was just kind of fragmented bits and pieces that were also present in that first 64K. So it was effectively a 64K clean dump of a chunk of firmware that was, let's see, so where was that? I didn't actually dig into going super deep on finding out like how that address was coming about, and how I can affect it. I did some experiments to try to affect the address, but I saved a lot of that for this because I figured a lot of that would change substantially depending on what the program is doing as you're glitching it. So I still need to find out whether I can change that address to get more firmware out, or if I can, it's also possible that just that 64K gives us something that would be usable, since at least in my test setup, it was just a nice chunk of firmware. It wasn't like way out in the weeds. It wasn't just like all data segment. It was like a lot of text segment goodness. So, I have no guarantee that the results here will be anywhere as good, but I can at least try. And it seems like it's worth doing that right now. Okay, let me make sure these are good, and then let's find a place for the clock. Man, it's like weird how much it can break my concentration having somebody with a package show up at the door. I guess it would maybe be a little less weird if I had a doorbell here, but usually it's just like, hello, hello, is this a thing? Are there people existing in this address? Hello? So, the signage situation in this whole warehouse is kind of weird. Delivery folks are usually a bit confused when they show up here. Okay. So now we have a reference point for putting this connector on. Oh, I think I meant to be showing the microscope because that's what I was looking at, but actually the camera is a little more useful for this if I actually aim it right. All right, so these two on the right need to be ground. So I will stuff them there. And then that gives me a lot of free headers to work with to the left and right of that. But it means I don't have to redo the stuff that I've already put together on that wiring harness. So, that blue wire is what we want for clock. So that's what's going to this resistor that we just put in. Oh, nice. Len in chat says that I could put up my own signs or paint a lime on my unit like they have in hospitals. And actually, I have some decorations in my door since, the landlords around here don't mind if you put stuff on your door at least. So I actually made a vinyl picture of Tuco for my door here. I might have to show that on the stream sometime. I like how it turned out. Yeah, I have a little lime sticker and a picture of Tuco. So it's a little bit recognizable if you know what to look for, but like random delivery folks are not going to know to look for that. Unless all the packages also had the same sticker. That'd be an interesting address system. Like you don't accept a package. Oh, I cannot hold this at the right angle. Like you don't accept a package from somebody unless it has like an image that only you know that you would have previously sent them. I mean, still plenty of room for man-in-the-middle attacks under a system like that. Man, network security and physical security sure are different, but still highly interrelated beasts. might have to hold this with actual tweezers. Yeah, that's better. Fifth from the right. Oh, there's a question from Doomel29, a newcomer to the stream, wondering what's going on. Basically, I'm preparing this device here, which is the guts of a programmable logic controller, so basically an industrial Arduino. And I am trying to get it ready for this experiment, which I had mostly ready to go, and then ended up kind of diverted from because I broke the last PLC I was doing the experiment on. The experiment is designed to try to extract a firmware image, or at least a partial firmware image from the device, by hitting it with a voltage glitch while it's trying to figure out what to respond with in its little onboard web server. So it'll be trying to serve out like an index.html, and I hit it with a glitch at just the right time, and now it ends up corrupting the pointer to that data and then sending me part of its firmware instead. And so that's the theory. And I've got that working in kind of some other less realistic scenarios. Like I made a mock-up of this using an eval board with the same chip on it, and that I got that 64 kilobyte dump successfully from that board. And then I was trying to replicate that success with the actual PLC, and then ended up with an unrelated problem that I was distracted by for a while. So this wire I'm attaching is a clock input, which will let us kind of step this through its paces at the same, at a controlled rate. So it lets us do a couple things. It lets me lower the clock rate, which can make some of the experiments easier. It also lets me keep this synchronized with some external hardware, like an FPGA that's running my own triggers, or the chip whisperer, which is doing glitch injection. Tuco's yelping in the hallway. I hear the little bugger. Hey Tuco, what do you want? Also, that's my cat. He's often hanging out here. Oh, and then Robert in chat asks, I wonder if the embedded web server has any trivial buffer overflows. That's a good question. I've looked a little bit at the code that I have access to. So the web server seems to be based on like a publicly available sample from TI. And I've looked in there. It seems to be all right. It's actually also based in turn on the example HTTP server for the LWIP stack, which is an open source project. And it seems all right. Like there's certainly plenty of room for buffer overflows in the code that they've bolted onto it to handle their own application-specific stuff. So I'd love to look for that, but that's like something I'd like the firmware update in order to do. Like once I have the firmware, I could reverse engineer to try to find that stuff rather than just having to do it all via black box fuzzing, which is a lot slower and less likely to actually show you how to exploit the problem once you find one. Oh, nice. The newcomer, Doomel29, says that the only reason they found this stream is because they remembered me from when I did the propeller USB host and the ATtiny RFID tag. Yeah, those were fun projects a while ago. That is also one of the reasons that when I started streaming stuff on YouTube, I ended up just using the same YouTube channel I'd had forever. And there's pluses and minuses. It means it's not quite branded the way I would. It doesn't have like scanlime featured on it as much as I'd like. It's got like my ancient Google handle as the actual channel name, but at least it was something that some people already knew about from previous blog entries I'd posted with video attached. Aw, Dr. Toon says the AT-Tiny RFID tag is one of my fave hacks of all time. That's really sweet. I appreciate that. That was a fun hack. I mean, to quickly mention it for anybody who hasn't heard of it, it's basically a way to build your own RFID tag using an AT-Tiny microcontroller. If you search for AV RFID, I think you'll find it pretty easily. It had a handful of really nasty hacks that made it work. The actual coil that you attach it to was powering the microcontroller through some of its I/O pins and also providing clock. And then those I/O pins were being used as shorting transistors to drive the current signal back into the RFID reader. So it was really just an RFID tag with two components, like just an AT-Tiny and a coil and an optional capacitor, but it worked even without that. I think this little guy is our reset. Let's take a closer look at that. Ooh, I need to log into this laptop again. Ooh, getting a coffee and a sandwich does sound like kind of a good distraction to do soon. Oh, pin diagram. I think it was bottom right corner-ish. Okay, yeah. Tuco, you have a bolt. I can tell. I feel it. It's right here. You're also very far from the camera. Can I throw this back toward the camera? Oh, I missed. Hey, Tuke. Oh, you dropped it way over there. Tracking him around with the zoom lens from a farther distance is going to be really fun. Alright, let's find this reset. Geez, really? Windows is trying to make me restart the PC that I'm attached to the chat with. Later, please. Oh, neat. Robert in chat mentions that they made a something similar to the propeller RFID that I did, but with a Stellaris arm instead of the propeller. Oh, that sounds great. I'd love to see that. Because I was curious, so that's another hack where I did that before making my own RFID card. I made my own RFID reader, and I was also kind of trying to do that in the very simplest way possible. So actually, since we're on the computer anyway, I think there's a schematic here that I can bring up. Yeah, there's an old blog post I made about this. That's the RFID reader. So this is a propeller processor, which is a fairly high-speed processor that runs multiple cores and lets you do a lot of bit bang I/O pretty easily. Yeah, so there it is with a big antenna. But I also got it working with smaller antennas, but it works a little better on big antennas. There's a schematic in this forum post. Yeah. So yeah, I'd be curious to know if anybody's tried this with other microcontrollers and how it really ended up working. This is done with a bunch of really weird software tricks. Basically, okay, so which is which? So this coil here is the actual antenna. So we're energizing the card by driving a differential waveform across the coil and a tuning capacitor using these carrier outputs. And then the input is sampled So this is one of the pieces that I thought might be hard to port to another microcontroller. The propeller has a really weird GPIO block where the inputs act like comparators at half VCC, so they don't have the hysteresis you would normally have. So in that case, so this input acts like I have a comparator with a 50% VCC reference, then going into a regular I/O pin. And then basically, I, in software, generate a bias voltage to give me an arbitrary comparator threshold for sensing. So this threshold output is a pulse width modulation signal from the microcontroller, which goes through this filter to give me basically a DC voltage, which then R3 kind of uses that voltage to kind of nudge this input signal up or down. Basically, R3 and R2 and the impedance of this whole circuit end up forming a voltage divider there. This R2 actually I don't think is technically necessary. Like R2 could be omitted since this is in. Oh, Tuco, you're sitting right on the keyboard, honey.
VoiceOver speaks descriptions of items on the screen. Alt your keyboard. If you already know how to use VoiceOver, press the key down.
Tuco, I don't know that I already know how to use VoiceOver, but it's also not necessarily what I wanted. Computer. Well, I think we can just do that soldering. Oh, cat, I kind of needed to look at the pinout really quickly. Okay, 6th from the bottom. I think that was just on a capacitor. I think they had a little smoothing capacitor to keep glitches out of the reset signal. Yep, that's it. So that's the reset we want. I think it doesn't really matter whether I take that capacitor off or not. Like the timing of the actual reset signal is never critical in these experiments because the processor always takes a somewhat unpredictable amount of time to come up out of reset once you reset it. So, I need the ability to send a reset just whenever the experiment reaches a particular point and I need to run it again. But the actual signal integrity here is not important, really. Oh man, I could get coffee and a sandwich. I think that might need to happen soon. That is my new fantasy. Typing under cat as observed by Len in chat. Yes. As sometimes becomes necessary. So reset, where is my reset headed? Reset is the green wire, which is second to the left. And the yellow one is currently a no connect. So I assume that was something trigger related that I'm currently not using. But I know I need to break out GPIOs anyway. I just have a decision about where to put those on the connector, and I think I might put them elsewhere. I really don't know how Tuco got to be so photogenic. Like, he's just really good at looking beautiful. I know that's not really something he would have control over, but it's certainly a nice happenstance. Nice blob of solder there. All right. So I need to solder some GPIOs. I think before I do that, I want to take a slight diversion to put in these Ethernet jumpers. So this is to bridge over the spot where there used to be a transformer that no longer is transformering. I think first I want to give myself a little bit of insulation. Don't want to be shorting those pads out. Yeah, I was thinking, well, I could just use those, but actually this one's damaged, so. I didn't use them last time because I ended up just like ripping off the transformer and it took most of these pads with it. But now they're not quite fully intact, but also not, gone enough that I don't need to worry about them shorting out, so I do need to insulate these a little. So I mentioned before that I don't know if this modification is actually necessary. It's something that I started doing during one of the experimental phases in my Ethernet underclocking, and I haven't determined for sure whether this is necessary, but it seems to make several things easier just given the setup that I have right now, so I've been sticking with the thing where I DC couple my Ethernet. It's not quite what I wanted. Maybe not the sharpest tweezers to be doing this with. I just don't like pulling with my good tweezers because that's a really quick way to break a set of tweezers. So sometimes I'll frustrate myself a little using the bad tweezers for a bad job instead of risk messing up the good tweezers. This one is also cat hair composite. Thrilling. Oh yeah. Dummel29 in chat says magnet wire and how hard it can be to solder reliably to stuff always puts into perspective just how small 6mm traces are. There's so many different kinds of perspective too. It's like, you can be used to working on a certain kind of small electronics, and then somebody just brings in a design that just totally blows your mind with smallness. I suspect there's still another decade or so of that happening. So, how did I do this before? I think I want to solder across the RX plus and minus, the TX plus and minus, and leave the center taps alone. I'm just going to look at the other board to verify that's what I did. Yeah. And there's a lot of DC current flowing in, well, not like a lot, but like a necessary portion of the communications happens due to DC coupling elsewhere, given the strategy, but it seems to make for... I mean, I think a lot of what it's doing is it means that for most of my Ethernet signals, I can treat them as 0 to 3.3 volt sort of signals instead of small signal AC signals, so that I can do things like use the FPGA to trigger directly on the 10 base T packets or send that into my scope and not have to worry so much about the signal. So it's definitely a hack, but it seems to be effective so far. Oh man, this is almost too big for the microscope. Can I just do this on the DSLR? Can the microscope be less zoomy? Not really. Kind of doesn't focus once I zoom out that far. Oh, that's a little wider. Great. Oh, if anybody's still like, what the heck is even this voltage glitching stuff? There's some other YouTube videos you might find interesting. Colin O'Flynn has a few videos on Chip Whisperer and related kind of introductory glitching stuff. I also put out a video on kind of this project's predecessor, which was using the same or a similar voltage glitching technique, but communicating with the device over USB, and then while it's sending back a USB descriptor, glitching it so that it sends back some firmware instead. And that was enough to get me just a clean firmware dump of the entire mask ROM I was working on. So yeah, if you go to my blog site scanlime.org, I think that's still the top video on there. That one I don't list like every stream on there. I just post the ones that have like hundreds of hours of editing going into them. Oh, Robert also mentions that capacitively coupling Ethernet is possible, e.g. for cascading some switches. Yeah, someone a while ago pointed me at actually an app note for TI that I think was designed for maybe not this one, but at least some of the PHYs that they do that are in a similar class, and talking about how to capacitively couple them. I think I was doing that for a while. I might have stopped while I was doing the underclocking experiments just to have another fewer things to worry about for underclocking. But yeah, actually, I might even still have it on my other desk. I made a cable for this test setup, which replaced the Cat5 with a breadboard with some capacitors that I could change out. And that was useful to a point, but wasn't actually necessary, it turns out. And it made that earlier stuff I was talking about, like triggering on the signal and having it be like treating it more like a DC coupled thing instead of an AC coupled thing, it made that part harder because part of the setup is actually wanting it to be DC coupled rather than just not wanting the transformer to be involved. And then part of it was, wanting to try other methods of coupling in case the transformer had the wrong frequency response for this. And so of course I worry about DC current flowing from transceiver to transceiver in a way that would break stuff. I did, when I was first putting it together, try it out with a current meter in the loop, and it seemed to be just, a few milliamps like what you'd expect, so I didn't worry too much about it. But definitely a hack. If you want to do a similar thing and it be less of a hack, then definitely check out TI's app note on capacitive coupled Ethernet. It's a little close over there. Oh man, I think somebody is cooking something delicious. Well, I don't even know if it's delicious, but maybe I'm just hungry. Maybe I should eat lunch before streaming. Ha ha ha. Some of these are a little gnarly. I might just put some Kapton over it to hold it mechanically and then reflow them with some fresh solder. So if I'm doing that, I'm not going to fuss with these quite as much. I'm just going to tack them down. Oh, Emily says no lunch and it's almost dinner time. Well, I'm on a little weird schedule, I guess. I don't know. Who eats lunch at 12 anyway? I feel like breakfast should be at like 9, and then lunch should be at like 3, and dinner should be at like 8 or something. I don't know. How does human even work? Alright, a little more soldering. Alright, that'll do. Oh, do I have energy for GPIOs? Those go over here. We don't need all of them, but I need at least the left 2, and might as well have all 4. Too much solder. Just trying to clean those bottom pads a little bit. Alright, let's get 4 pieces of magnet wire. Or rather, I'll just take this piece and fold it. And cut one end off and tin it. I want to get this experiment going again soon, but I'm also feeling remiss on my cat camera duties. And so, especially now that I've got a few more of the parts in the mail, maybe I will try to wrap this up soon and then get myself a bite to eat and then do some cat-related CAD. I guess I could do that on or off stream. A lot of this stuff is easy to stream. I think mostly it's just I have to keep an eye on how much social energy I have. Like, it feels still more, I don't know, more sustainable to do, you know, not by much, but a little bit more sustainable to be doing something on my own than to be talking to a bunch of people about it. And so, I don't know, it's just like social energy of some sort needs to refill every so often. I could do like a silent CAD stream where I don't talk at all, I just have music. I wonder if that would be fun. Let's trim the other end too. Alright. Got a few of these little dudes. Their laptop is still blowing its fan like it's super warm. I wonder what it's doing. I wonder if Tuco started it mining Bitcoin or something. Oh geez, that needs a lot of flux. Oh, nice. Oh, Emily also, who's in chat, mentions that that I can do anything I want with the cat ASCII/C64 art that she sent, which I should show on the stream. It's really good. She made some Tuco the cat fan art. Let me see if I can find it. I know I saved a copy of it on my phone, but I think, oh man, there's a bunch of or a bunch of Twitter I haven't kept up on. Hey Tuco. Oh, there it is. Great. Let's get this on the screen. Yeah, Emily made this Tuco fan art. It is super cute. Cattail. Meow. Alright, let's see if we can do a little more soldering before I run out of steam and have to immediately abort and enter sandwich mode. Hey Tuco. Things are about to get fluxy in here. Let's use some more of the thick flux for this job. I hear you, little cat. Gooey. 2. And wires 3 and 4 are slightly tangled with each other. Three. All right, I think that's all I needed there. So these are logic level outputs that would normally go to the relay drivers on the other board, but I'm using them as general purpose outputs, one of which I'm using as a trigger signal for the HTTP request I'm interested in, and the other I'm using as a timing reference that I'm toggling every time the PLC goes through its main loop. And together, the FPGA uses those to figure out when the experiment is actually happening. So one of my small goals for this actually was to not obscure the processor so much. So actually, it might be worth trying to route these wires around the CPU so I can still desolder the CPU if I want to do so later. In that case, maybe some Kapton tape assisted routing. Maybe hot glue or another kind of glue. Maybe this is a good case for a UV cured glue. Oh, where's my little brush? Oh, there it is. That needs more isopropyl. All right. Just want to bend these back. Yeah, this is a good job for a little bit of glue, actually. Warm that up. Where am I taking that? I could bring it over there. I think this is probably a good spot for it. Just kind of forming these leads into roughly the shape I want. And then I'll solder them one by one so it's easy to get the order correct. I guess I could just use the leftmost 4. That might be easy. In that case, these are only a little too long. Just trim that right about there. Now I will tin them, solder them to the right place, and then hopefully by then the hot glue is warmed and I can just tack them down and strain relief around where they're actually soldered. Oh yeah, and just, if anybody's wondering for some more context about this stuff, because I've certainly been building a mountain of context in these streams over the last while. Basically, there are 2 ways that you can find like video content that I've been doing. You can watch previous stream archives. So anything that is Senrio related, I've been updating or uploading to the Senrio Labs Vimeo, and I've also got archives on YouTube. And those, if you just want something to like hang out with over a long period of time, those can be nice, but they don't really get to the point quickly. For that, I eventually end up releasing edited together videos with just really fast, dense versions of the stuff that I do. And so those don't come out very frequently, but when I do release those, I put them on my YouTube and on scanlime.org. So that one, like if you want just more of a like rapid fire overview of what this voltage glitching stuff is about, then that might be useful. Or, for voltage glitching specifically, there's a lot of other content on YouTube that you could check out by folks like Colin O'Flynn. It's been nice to see more people do reverse engineering on YouTube too. It's nice to see even Dave get into that. Oh, let's put that in back and bring this to the front, sorry. That is fun, but not quite what I wanted. And here's the part where I totally failed to have any depth perception with this stuff. Also, the microscope is a little bit too low. Solve that problem with some angular displacement. So yeah, there's a few things in between the signal path, from the chip to these relays already. I haven't looked closely at the I/O board, but I guess it's also interesting to me that these are digital. Like, I would have expected there to be some kind of like serial I/O expander thing going on, but I guess maybe they support that for add-on I/Os, but these built-in relays are still just connected to plain old digital pins, which is nice. It's easier. It's not what I was expecting, but it means I can use them as fairly consistent timing references. So then the other board has, like the transistor that's actually driving the relay and the protection circuit, the diodes so you don't end up destroying the transistor with the reverse voltage, all that stuff. This board still has a little bit of protection. Like they have so the resistor bank that we just disconnected, or that we desoldered to make room for these connections, was I think like a 100 ohm series resistor between each of these I/O pins and the other circuit board. So I have to imagine that under normal operation, that resistor would do very little. It might be like a slew rate limiting thing so that there's less electromagnetic interference when these change state. Or it might be, some kind of safety feature in case there's a fault in the other board. Okay, so let's try to do these in order. I'm going to start with the one that's on the left. This one. Now the microscope is too high. Okay. Okay, that's still the left one. Next. This one, I think. I'm just moving the wire a little bit and watching for the corresponding wobble on the other side. Yeah. Two more. These are a little twisted, and so they're both moving. Okay, that's the last one. This is the next one. Okay. That might be a good stopping point. I think we're getting close to having everything connected. In fact, we might even be able to power this thing on. Those, just gonna kind of bundle up a little bit. Want them to be out of the way, but not hard to modify. Maybe I don't even need to glue them. Just forming the wires a little bit. Well, let's just put a little glue over here, like on the actual joints, but still this, maybe even just a little right here. This doesn't need much drain relief at all. This is pretty lightweight wire and everything. I've already got the hot glue gun warmed up. That'll be easy to isopropanol off later if I need to, but... Ooh, let's keep it away from the chip. I mean, not that I can't get it off the chip later if I need to, but I really don't want it on the chip. I mean, clearly this hot glue is going to melt if I'm hot airing that chip off, but I can just take this off before that if I need to. Stay. That's ugly. Well, speaking of hot air, just a tiny bit of this. That should be better. Boogers. touching it again. Oh well, that's fine. It doesn't need to be perfect, it's hot glue. I perhaps shouldn't have just put any glue on this. I guess I could just take it back off if I decided I really need it. Fine. This will be cleaner without glue. This is easier when the glue doesn't wrap around the wires. But this should still break apart. Alright. Maybe I'll just leave it like that. With this. Oh, that's totally come apart anyway. Fine, no hot glue today. We'll just replace this bead of hot glue with some Kapton tape. Was that not quite dry enough yet? Maybe not. Well, that'll keep it out of the way while also not disintegrating when it gets hot. So maybe it's a win. I think I might also just be approaching the state of being hangry until I get a sandwich. I want to power this thing on though. Can we do that? We've got clock input, reset. Yeah, let's power this on. I want to see it power on before I end the stream. That would be satisfying. All right, 12 volts. Power. Okay. Get this ready and then get the clock source running. Okay, power supply is ready to connect at 12 volts. We have 5 volts for the Raspberry, network for the Raspberry. Again, because of Wi-Fi not working especially well around here. Then this goes to USB. Good cat picture. Let's go to the other computer though. Is that what we're doing today? Is my VM still happy? Still plugging away. 879,000 experiments on the SD card emulator brute forcing experiment. This is mostly unrelated to the content today, but this is trying to guess the file name that the bootloader is expecting on the other PLC that I bricked. So let's leave that. Let's go to the Chip Whisperer VM. yeah, that's already plugged in. Let's just run this and get it pumping out a clock signal. Run, run, run. Run, run, run. Okay, scope. 27 megahertz. So that's good. Let's start up the FPGA that's doing the rest of the clock synthesis. And let's just double check that we don't have the awful clock speed changing stuff enabled. So the clocks that we've got are these two, Ethernet and MCU clock. And that should be our fixed divide by 24. So that all looks pretty safe. Let's load that into the little FPGA here. Oh, those are Tuco's favorite birds. Oh, did I end up giving that to the VM also? Or... Oh, I think I need to unload the FTDI driver. Oh. There we go. FPGA is blinking away happily. You can see the LEDs on this thing. That was the board I just loaded code into, well, loaded hardware into, and it is now synthesizing the clock that I need. It's also got some trigger logic in it that might still need some work, but I'm going to ignore that for the moment because I just want to get this power on. The scope is not on, but I really want to verify this clock before I power things on. Let's get a probe. And let's turn this back on so we can see the scope. That'll come on in a sec as the scope boots. Ground and clock. Nice. 5.6 megahertz, I think that's right. That is the clock that our FPGA is generating. This is normally 25 megahertz, but I'm underclocking it. I think we're ready to hit the power and hope this thing works. And if this works, the next thing I think to try is the low noise amplifier. All right, 12 volts, 70 milliamps, starting. It's just like it's not bricked. Imagine that. So here's our backup PLC functioning. Not especially servo. Maybe I was just zoomed in too far. Anyway. So there are a few places this can go. So I should test the low noise amplifier. I need to load the PLC program on here that goes with my experiment. So that requires connecting this to the network through my bridge, actually setting it up as an Ethernet bridge, and then connecting that to the PLC software, so that I can get the software or get the the PLC design loaded onto here, as if it was all on the same network segment, and that'll give me these GPIO outputs. The sketch that I'm loading on here, the PLC wiring program that I'm loading on here exists entirely to give me useful signals out of these 4 wires. So that'll give me, 2 of those are unused right now. One of them will give me a signal when the HTTP request I'm interested in happens, and one of them will just toggle continuously as a way of predicting the timing of this thing's main loop. I think that's the stopping point for today. Oh geez. Phil in chat says that he's found the firmware update on the Siemens website for a click wireless PLC, model number CMR 2020. I don't think those are related. Like, I don't actually know about that model. And then the name of the file name, he says, is CMR 1427, blah, blah, blah. It's like a version number and a date code with a .sfe extension. But yeah, that seems unlikely to be a file name that it wants. But just for reference, the model that we're dealing with, I've got the shell over here. It's the new logo series. I think the model is 0B8, 0BA7 or something like that. The weirdest model numbers. Like, I don't know who comes up with this stuff. Yeah, 0BA8 is their model number. Focus. That's what we're dealing with. So, like, I haven't looked at the Click series. But yeah, I don't know if they would be using the same processor. And then Robert in chat says, I wonder if you could find an exploit in the PLC program bytecode interpreter. That's pretty much the kind of thing that we want to look for as soon as we have firmware. Because, I mean, it might be possible to find that kind of thing blind just by trying modifications to the PLC firmware or to the PLC program. And there are probably ways we can speed up that process, but it seems like, one of the things that might be really useful just overall for a lot of these kinds of potential vulnerabilities is to have a copy of the firmware, or at least a partial copy. So that's why I've been focusing on the extraction effort so far. But yeah. Yeah, Mike in chat says I need AVE's voice-triggered focus control. I definitely do. Yeah, 24 volts. Anyway, that's what we got. I don't know of any off-the-shelf firmwares for this, and I mean, it's easy to get file names that it finds interesting on the SD card once it's actually booted, because I mean, like, I can go in here and like save. I think it's under program. Oh, this is a different program. This is, I guess, something my coworker Margaret was experimenting with, maybe. Oh, is it card? Yeah, so this stuff. Like, I've experimented with this a little bit, and I've seen, like, the program is in just like a binary file that seems to be a very straightforward copy of the MRAM or the flash, or the SPI flash on this board. Do I have an SD card handy? I mean, I have my emulator over there, but that's not super helpful right now. So I don't know. I mean, there's information out there for the PLC program on the card. I mean, to some extent, like I haven't seen anyone really pick apart the format, but then like the PLC program seems to be the thing that they let you modify it, whereas the firmware they don't really want to acknowledge that it exists other than as a version number. With the card in there, let's try save program to card. And did that give me anything I can find? Oh, there's a springy latch in there. I took the spring out of the other one because it wasn't doing me any favors. Gotta have a card reader. Floop. That's my little tiny caps lock. Oh yeah, so I had a bunch of files in here. Great. That's the one I just saved, logo up.bin. That's the PLC program. This is part of why when I was just manually flipping through file names, I was trying a prefix of logo, but I don't think I tried that since my more sensitive experiment, but if that's the prefix, it'll find that. I mean, I don't think it is since I already tried all the regular alphanumeric combinations. Oh yeah, US Water Rockets asks if I ever tried logo up.bin on the SD emulator, and yeah, I didn't see anything special for like this prefix, so, and it would not be looking for this file name. Like this is not firmware. This is just like a totally different thing. Mostly empty, little suffix. Yeah, I mean, it's certainly possible this file name has some interesting, or this file has some interesting vulnerabilities in it, but so far I haven't spent a lot of time just blindly reversing the file format, and I've just been focusing on trying to get the firmware out first, since if you were to find the vulnerability, you would probably still need the firmware in order to figure out how to exploit it. Oh, that's interesting. Robert in chat says that they've managed to dump the firmware of a .NET Micro implementation by writing a clever program using pointers in the unsafe blocks. Yeah, that seems interesting. I mean, I doubt that this has anything resembling a pointer. It definitely has something that looks kind of like registers, but I expect that the ways that they would be encoded wouldn't be wide enough that you could use them as regular pointers, but yeah, I mean, that's the kind of vulnerability I would love to look for once we get further down this. It's just that's kind of a different branch of the experiment than what I've been focusing on right now. Because that's something that is largely orthogonal to the process of actually getting the firmware out. You know, we might be able to get some progress in there just by blindly poking at the file, but having some firmware will make that whole process a lot nicer. Wildmania is asking if I tried this file in binviz. I don't think I did. I mean, it's mostly zeros, so it's not going to look very interesting, but we can take a look. I mean, I suspect that it's just going to be a header and then a bunch of, like an array of states for each of the little logic blocks that you can program and connect together. I mean, it'll probably look a little bit like an FPGA, honestly, with like a bunch of little things that all like have some routing to each other. But I don't think that routing is going to necessarily just be pointers, at least not in the ARM's normal address space. Actually, this is another thing this is reminding me of. If anybody played the old video game Robot Odyssey, it was like basically an adventure game about programming robots using schematics. and it had a little way of letting you wire up circuits inside the game that would then run the robots. And so I played this game as a kid, and then much later on ended up going back and reverse engineering that format. And I imagine it would also be a lot like what this PLC is doing. So yeah, mostly zeros, or FFs actually. So I guess this is erased but unused area in flash memory. And then we've got something starting at the end and growing up, and then something starting at the beginning. Let me make this. Is this easier to follow if I make it side or scan back and forth? And these might be the actual settings for those logic blocks. That thing at the front might have been just like a table. So this is kind of interesting. I mean, we could certainly go further into this file format. It just hadn't seemed totally relevant so far for... Like, if you could use this to get a firmware dump, that might be worthwhile, but from what I've seen, the PLC software doesn't have primitives that seemed likely to have memory, or at least like arbitrarily accessible memory enough backing them, but yeah, that would be interesting. And up here, you know, like these definitely have some structure to them, but I didn't recognize just right away what these were. Like these might be different type codes, or like this looks like something that's either constants or like bit fields or something and repeating. These don't look like addresses or instructions necessarily. And then this stuff. Yeah, I mean, it looks like, I mean, there's some hints that maybe there's a bunch of 32-bit values in there, a bunch of things that are probably like bit fields ORed together, some 16-bit values and some, you know, some offsets and stuff like that. Nothing that's like, obviously, this is where you put the shell code, but definitely some threads to pull on for sure. But yeah, I suspect this will be much more interesting once we've at least seen some of the firmware dump, which we seem to be pretty close to just using the current strategy once I actually finish wiring it up. But I think this might be a good time to take my sandwich/coffee break. Oh, right, there's one more easy thing. I wanted to take a look at the voltage output there. It's still possible. I need to add some more cleanup on the 3.3 volt rail. So on the other instance of this board, I actually went to quite some trouble to filter the 3.3 volt rail, but I don't know how much of that is actually necessary now that I have a more stable setup in general. So let's just see if there's anything, like see what the general level of messiness or stability looks like on the power. So that goes over here. It's a little bit of a tight fit this time around. Maybe I need to use a little SMA cable or something. Well, there's all the clock edge noise, which is, you know, what you'd expect. Can we get anything else this processor is doing that's worth correlating to? Maybe LCD activity, or... I don't think it's going to be talking on any of the buses very much right now, but Yeah, maybe I can put the scope on the LCD and watch it redraw. I think some of those were interesting. Oops. Where is the bigger scope screen? I forget where I put this one. No? That's the one. I've got to remember this button. Oh, it's this button. Man, this is just where I get tripped up when I'm trying to remember which button is which, and then I have to also navigate the fact that sometimes when I press the button, it actually does the thing that a different button is programmed to do because the analog buttons aren't calibrated super well right now. All right, so that's that. Okay, that's one of the LCD signals. Is that the same signal? Yeah. That's a relatively easy place to leave the scope probe. A little too close. Maybe bandwidth limiting would help here. A little bit. Well, this is kind of inconclusive. It doesn't look good, which could be, I mean, like I haven't tried this exact experiment before, so I don't have a control. I don't know if this is actually going to show me CPU activity during screen update, but it also looks noisier than what I would expect. And it certainly could be possible that I need to add a bunch more filtering for this to be useful. Oh, that's also a good question from Mike. Mike says or suggests looking at the timing of the SPI flash read to see if it's pulling small or big chunks. So far, it looks like it's reading the whole thing into RAM at boot. I notice. Well, so actually, if I need a timing side channel, there are a couple of other options. I can definitely use the relay outputs, which is what I've been using so far. I haven't looked into this so far, but I think I could write variables into the MRAM and then sniff that bus to see them going out. There might also be other things to do with that because the MRAM and the SPI flash share a bus. They just have their own chip selects. So yeah, the MRAM might be an interesting way of getting data out. As far as having a side channel for evaluating just like where it's currently looking, I don't know if I have a good way of doing that because it does seem to be running the whole program out of RAM. But yeah, I'll have to take a look at that. I think right now it's time for walk and coming up with plans, but you know, I mean, it's good to keep the idea brainstorm going because I can certainly use some more plan B, C, and Ds, and I usually end up on plan A.5 after all is said and done. So really, I think it's good to have some other plans in the back pocket, but I think the plan A here is still to continue assembling the setup, get it running my voltage glitching web page retrieval thing. I don't need this power side channel amplifier really to run that experiment, so I don't need to necessarily do the filtering first, but it might help. So as for soldering, I mean, the filtering I did on the other board was pretty extreme, but what I might do here is to just try first just putting a big capacitor across the 3.3 and see if that helps, or like a few different capacitors. On the other board, I also separated the 3.3 and added a resistor to make a little RC filter. But yeah, I think we're getting close. Yeah, there's definitely a lot to look at in terms of the PLC program that I have not yet investigated. I've just been mostly going by the Java code. And actually, for figuring out the PLC program, disassembling the logo like graphical editor might be a route to do that also, since it seems to save things in pretty much the same format, and it's all fairly easy to decompile Java code. So if we really need some format information, it might just be sitting there in the Java class file for our taking. But yeah, thanks so much for the suggestions and ideas and company. It's always very appreciated. Oh yeah, we're also marveling in chat at the accuracy of the ragdoll physics simulation on Tuco. Yeah, it's pretty accurate. You can even see him breathing. It's pretty rad. Yeah, it's also getting toward evening here, so maybe I could even context switch and work on the cat camera some, because that would certainly be nice. Oh, and Dr. Toon suggests trying a buffer overflow on the DHCP. I don't think it does DHCP. I think it relies on static IP. But yeah, so as far as I know, the protocols that it does, it has an HTTP server, which is pretty minimal. It serves out mostly static content, but it has a simple like REST API, which seems to be a thin wrapper around some other legacy protocol that they probably also speak over their other ports. Then they have like a whole separate protocol that I think people have been dubbing S7, which is what the PLC software speaks to control the PLC. If I remember right, that's mostly TCP, but I haven't looked into that super closely. I watch it go by in Wireshark sometimes, but the communication I've been mostly focusing on so far has been the REST requests that the JavaScript web client makes. That's how I've been triggering GPIOs, by sending those, but I think that's just a layer on top of something else that you can get to through other means. Oh yeah, Kyle's mentioning we're definitely at the time of day where I mutter something about needing a sandwich. So yeah, sorry to be so predictable. But yeah, I think that's the thing. Well, thanks for tuning in, everyone. Thanks for joining me on this PLC experiment. More on this and everything else shortly. Mike in chat mentions, or asks, how annoying would it be to get all the way through this, get the firmware, and then find out it has absolutely no vulnerabilities? That would be kind of annoying. I think it would be more annoying if I did that and then also found out that the chip had been discontinued and nobody else used it anyway because it was just terrible for other reasons that I never noticed. Which could happen, but yeah, I think if that actually happened, well, I'd be really impressed because this kind of software never has no vulnerabilities, but it's certainly possible that they did a better job than average. Yeah, if that actually happened, I think I would just end up trying to pack up my experiment and move it to a different target. So, yeah, there's always another target using similar equipment. Well, thanks for tuning in, everyone. I will see you on the flip side, wherever that might be.